Fixit42 bot says welcome. Stream starts in 5 minutes. Fixit42 bot says T-4 minutes. Fixit42 bot says T-3 minutes. Fixit42 bot says T-2 minutes.
Welcome to my stream, where knowledge reigns supreme. Calm and collected. I'm about
Fixit42 bot says stream about to start, 1 minute left.
patience. Gonna teach you something new. Learning, hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel the secrets. I'll unlock the code. No limits, no boundaries. Our knowledge will
Ho216 says best viewers on samanthalewis.com/G78E. Trizeli says CHEP viewers on SamanthaLewis.com/G78E. Woopinion says no sound. Is this normal? Or is it my side? Woopinion says I can hear TTS.
Yeah, so sometimes it's happened like, it hasn't happened in months. So I unplugged my mic and plugged it back in and it worked. So this is Windows and USB. That's annoying. So thank you very much for telling me about the mic, but that means that I've been quiet for 44 minutes. That's kind of like bad.
Woopinion says power management.
No, it has enough power. It's things like if I were to plug
Woopinion
in
says
an
disable
HDMI.
non-USB devices.
Why? Well, I'm just going to continue. I was
Woopinion
solving a
says
problem.
no, it's power savings by Windows.
Okay. Do you think so? That's very odd. Anyway, I have copied something. I need to paste it before I forget, okay? So I have to finish this. So, temp. So where I'm pasting the full thing here. And then I'm going to undo a lot of things here, which is kind of annoying.
Woopinion says Windows has this feature, but anyway you're busy, it can wait.
Yeah, I'll have to wait because I think I can't undo more than that. I might have deleted a lot of stuff. Well, so I guess we do still have video on stream, so let's pull that up and see what on earth was it that I actually might have removed. So let's see. So by the way, this is what it looks like. Everybody who hasn't disabled this new feature here, we can knock on their door. When you're streaming,
VR_Mechatronics
streaming.
says hey, how is going?
Hi VR, yeah, so Whoopin just told me I was muted until now on stream, which is kind of like, my god. Yeah, so we're going to go look back into stream, and let's make sure that this is muted. Come on. One hour ago it says. So let's hop back here somewhere. This is so annoying. Not only the muted part, but I... yeah, so I usually get this subversions. I haven't done that in some time. And I kind of regret that now, because I could have just looked at my last version easily. So I'm just going to pause that, compare it to the current document here. So yeah, the basic section exists. It's just called what is buffer overflow now. So then what? So I'm also doing my normal speed up speed. Doesn't it work?
VR_Mechatronics says I wonder whoa it was B, a TV remote control but for wife. If she talks too much she gets muted xddddd.
I think there's probably someone made a movie of that probably. Let's just make sure here that I have the cool. Yeah, they are there. So this, all of this exists still.
Wupinion says, so just briefly, Windows tries to reduce CO2 emissions by randomly putting USB devices to sleep if it thinks they are idle. Most of the time it works fine, but sometimes it is overzealous on some devices.
Yeah, okay, let's pause this then and look at it quickly. So where did you say we had it? Let's check power.
Wupinion says device manager.
So device manager, you can't do it this way. Additional power settings.
Wupinion says it's a USB setting.
Okay. Oh well, I guess it's easier to just do. So on the USB then. So my USB will look messed up, I think. SMS, USB. So I've got a few USB stuff. Yes, there's just a few.
Wupinion
USB
says on the root
here.
device hub properties.
Well, you can see I have like 1, 2, 3, 4, 5, 6 hubs.
Wupinion says top of the USB tree.
So on this one, it's nothing. It's got nothing. So let's look at one of the actual.
Wupinion says then try the device that was faulty.
Yeah, it's not here, since it's a mic, right?
Wupinion says power management.
Okay, let's
Wupinion
see.
says yes it is.
Here.
Wupinion says far right tab.
Here. No power management here. Here's just the description. There's no.
Wupinion says no option on the device.
Oh, this is the device. It's a blue snowball. So.
Wupinion says
okay. Yeah, so I also don't know where disconnected exactly. But it's a mic, so it's a bit special. I guess it's not here. But as you can see, we have USB devices here too.
Wupinion says okay then, but I had same issues with a mouse.
Yeah, but that's a different kind of device. And it was months since it happened, so let's do any device here.
Wupinion says sorry, fix it.
Oh, it's no problem. I love to learn new stuff. If you have knowledge of something I don't, that's great. So let's find the mouse. I think we can search even here, can we? Maybe too old. So this is like Windows 3.1. Looks right. The origin of this is long ago. Yeah, so USB is like the worst thing. So quite a few devices connected to this one. Well, I guess I could have hopped these. Human interface devices. Then we have mice. Let's look at my mouse. It has power management, right? As you can see, this one is grayed out because I have all power save off. So if it was a laptop, this would probably be on by default, but this is a physical, stationary
Opinion
PC.
says, yeah, that's what I had to disable.
Yeah, I imagine that was it. So if we look at one of the keyboards, it also has this. But it's all grayed out, so I'm thinking it's probably not even enabled. But for a mic, it wasn't there. So, but if I ever get it on a mouse, I know now that we can have that problem. So thank you for the help. Now I need to solve if I missed, removed some of my text, because I think I did. So I'm just going to 2.5 times this. I can even add more. Right, so you're on that screen. So I added the basic assembler. Sorry for this is horrible. Yeah, and then I removed it and called it low-level program execution assembler instead later.
Opinion says, are you doing the next season 6 HGB when it drops tomorrow? Fix it.
Oh, I didn't even think about or know it. So let's redo whatever I wrote here. So we have the last version of that assembler.
Opinion says, I was up until 5 a.m. getting root on Sightless.
Oh my god. Is it worth that? I understand, but if you were up to 5 a.m., it's because different time zones, and they had a new day later, so okay, so I guess the old season stops now then. Yeah, so I have this here. I'm like, maybe I already
Opinion
missed
says,
it.
no, it's just the 2 weekly box.
So I don't know what 2 weekly box is. So I haven't been
Opinion says, we're halfway through D6.
What is D6? It's not season anyway, right? Yeah, so I hopped over there.
Opinion says, S6, I mean season.
Yeah. So let's just look at this logically instead, and I can do that later. It's annoying. So if I forgot to, all right, I have the solution, I think. So Windows V, and we get a selection, right, of all the things we have moved here. So
Opinion says, I was kinda hoping you might want to join me on Discord for a team effort on a box sometime.
Okay, yeah, sure, that will be fun. So I miss doing boxes when I've been focusing so much on this, but now I really want to finish this, right, so I can continue doing other stuff. But because I think the buffer overflow, which includes all of assembler and understanding the low level stuff of the computer is kind of a big thing to know, and if you don't know it, you like miss the big piece of everything, right? So memory layout, the stack, if we do here, so the memory layout, I moved it and I've started rewriting it. So if I were to paste this thing here, this is at least quicker than looking at my whole video. So if I paste this here, this is the old version, so I'm just undoing, and then we Control V, program structure in ASM. Yeah, so do we have this here? We do, it's down here. So we have that. That's what might be what I thought of. The thing is that I reordered things so that one of my headers started and then this is like clear from what was above that I like removed. Stack pointer, yeah, so here we see here, this was probably after what I think I might have removed. Yeah, so this was me trying to get AI to tell me its password, and it worked too. So that was yesterday, and these are the spam messages. Then we have these things only. So I think I can feel safe that I didn't like miss anything. I did mess up the order though. So let's see. If I undo now. Yeah, so we were typing up here. That's what we were doing. And remaking this into text. I was going to start typing about stack frames, and then I remembered that I had stack frames already, and I moved this recently, and I added the registers here. So it says this means that, and I'm like, oh, what was it before? But I think now this means that for every function that is run, this is supposed to be after. It was after this about the functions. So we'll have to explain this in a short way to have it before. I was thinking it was more logical to have it before. We can't start this means. We can really just do this. For every function that is run, a new bit of the stack is used. The old top of the stack will now be the base of the new stack frame. The stack frame will contain and an extra space there. And this is what I had after the detailed explanation of what happens when you go into a function, what's the function prologue, and what does leave and ret, the epilogue, actually do in normal instructions. It's kind of funny that this doesn't have a special instruction and this does, you know? And this matters a lot for buffer overflow because we overwrite on the stack here, get the old instruction pointer from the stack. If we change this value, that's how we can control the program to hop wherever we want, since this is read only. Yeah, so I changed the order a lot. But I really wouldn't have wanted to drop this bit because it took some time to write this. Would have been bad. So let's go back and see if we can get an order of this. And I don't mind doing this all day, you know, as I'm learning stuff while I'm doing it too. So what is buffer overflow? It is like we can, like, if we write too much to this variable here, we overwrite this one. The buffer overflows and overwrite out the part of memory, and over this in memory, and it writes this direction. We have that EIP, the instruction pointer that tells it when this function, whatever it is, ends, where to hop in memory and execute. So that's what we're after. Oh my. Oh, this is a bad example only because it says 0 here, meaning that if the null character of the string ends up here, it says it's not overridden, right? Try again. Though it actually did. So, that's why I had a long comment on the image, or the code. So, memory layout. When a program is executed, two main areas of the computer memory are used, the stack and the heap. The stack. A thing you need to remember about the stack is that it grows downwards. This means that, for example, when space for a new variable is, well, I don't like declared. We'll see if what I'll change it to. The address of this will be lower than the last one. So what is the word I'm looking for? I guess it's okay. I just have a better word in the back of my head. The assembler instructions push and pop can be used to quickly add or remove something to from the stack, like a plate on a stack of plates. The reason for the name stack. This is when I was going to type about stack frames. When a function is called, a new stack frame is created on the stack. And I was like, am I typing the same thing I already had? Yeah, kinda, right? I'm actually going to do this. So we now have several bits here. Registers. And this one we can delete because I had another header before. There are a number of registers, tiny bits of memory with special purposes. The most important ones are there are also other registers, for example AX, BX, very high level, like not a lot of information, just the basics we need to know to understand the rest of what I'm typing. So memory layout. When a program is executed, two main areas of computer memory are used, the stack and the heap. Tiny bits of memory inside the processor. Yeah, let's say that. So that's good enough. When the program is executed, the stack, and then we have the heap, and then we have stack frames, which really should go there. So let's hop the heap to the top and start the heap. The heap. We don't have to say that it grows in a logical, normal way and not backwards, right? The heap. Well, we might use a heap for comparison and stuff. I was going to say it's mostly used for. Right, let's actually get a better explanation by getting some help here. And I'm going to open a new. No, it couldn't do that. So let's duplicate tab. Do new one. And do. Let's see if it remembers that I've told it to answer short, right? Because it's supposed to remember now. We can ask it. Please tell me what you remember. You prefer short answers when possible. You study cybersecurity, so I don't need to remind you about the insecurity or legality of topics unless you explicitly allow it. Okay? Explicitly allow. I think I said explicitly say or something. Yeah. Well, so it remembers short answers. So explain the use of the heap. Part of memory. It's different from the stack and a high level overview of all memory, right? The heap is used for dynamic memory allocation, meaning memory is allocated at runtime as needed, like when using malloc in C or new in C++ Java. Characteristics of memory, the heap is manually managed. It's the developer's responsibility to allocate and free it. The heap can grow and shrink during program execution. Use cases: objects, data structures, linked list trees, and large variables that need to persist up and function calls are typically stored on the heap. Yeah. So I was just going to add this bit, but it's good to have a longer one. Stack memory purpose. Oh, my kid's snuck in. Just a second. Yes, gubben. Yes. Det är den här kanske, att den är magnetisk. Ja. Den här. Den där ska i alla fall upp på vinden. Vi kan sätta den här istället så länge. Okej? Den där är ju bara färgburk. Den kommer den inte fastna i. Okej? Men den är inte, måste hon kan vara magnetisk. Okej. Jag fixar det, jag ska bara gå. Yes, I'm just going to quickly leave again. I thought I could switch mics. Let's see. No? Yeah, so sometimes my phone that controls stream needs to be unplugged and plugged back in to power, or it will say cannot charge and it will not update. So no, mic toggle there. So now we have this mic in my ear. It's not as good, but let's see here. Yeah, so I have to go and heat up some pancakes. I'll be right back. I'm going to talk meanwhile. So about the buffer overflow stuff. Right, the heap and the stack. So I think I'll probably still type what I was going to. But it's always nice to have a confirmation that what you're seeing is correct, right? By the way, I should have TTS'd it. Well, so I'm just opening a package of frozen pancakes. I wouldn't say I was sad when my kid decided that he thinks the ones you buy finished taste better than the homemade ones, because I've been fried pancakes since I was for 16 years, right? Every day, and that's a long time. Yeah, so the tiny extra cost of that is like, okay, he eats only 2 days. So I used to make a lot, not every day then, make for a few days. So where is it there? So we have this spray can of cream. Use this and we have some strawberry jam. Yeah. So I'm curious now to see if there was something new about the stack that I didn't know. And what else I would say? I might go up and guess it, but there is like 1 minute left on the pancakes. So I don't think I own worth bringing up the steps. So 40 cents. I also fried some hot dogs for chorizos actually for lunch. Yeah, water. I don't have water bottle upstairs. The dentist was amazed at my kid's teeth last night. 40-year-old. So, let's see, warm pancakes, some strawberry jam, and I'm going to roll it. If it's not hot, I'm kind of dying here. Hot, hot, hot. Ouch. Yeah. So is it worth, I'm going back and forth between this. Is it worth getting extra cutlery out just to roll a pancake so you don't burn your fingers? Or is it not? So I have to open the drawer, and then I have to get them, and then I have to And then so done anyway, and a tiny bit burnt because and for well, also my water. Just going to handle this and I'll be back. Så Laban, jag fick det vaxgubben. Hmm. Så gubben. Yes. Jag gör det samma som jag sagt varje gång. Så jag vet inte varför det blir varmare idag. Nytt paket. Det var ett nytt paket med pannkakor, men jag tror inte att det har någon betydelse. Now I have a big bowl of water instead of a tiny glass that's empty. So. What am I looking for? So. Yeah, right. So. Let's read the outline. Purpose. The stack is used for static memory allocation, for local variables, and function call management, including parameters and return addresses. Yeah, so it's nice that they have that too. Characteristics. Operates lost in first out. I'm allocating and deallocating memory as functions or called and return. So nothing is automatic. It is faster but has a fixed size set at program startup. I mean, automatic is depending on what language you use, right? Use cases. Local variables, function calls, control flow management. The differences. Alright, I think with automatic they mean that that's where stuff ends up without you having to say anything like malloc or something. If it's larger and grows dynamically, well, the stack's a fixed size and is limited. Stack is faster due to automatic. Heap is slower due to need of manual allocation deallocation. Stack overflows occur when the stack is full. Heap overflows lead to memory leaks if memory isn't freed. Right, so let's do a higher level. please chart all of a computer's memory, not only the use of one program. Of one program. Yes, I got a message. 1 second. I'm just sending a quick reply.
Cypher Enigma says GM.
Hi, good morning. Welcome back. Just 1 sec. I'm just going to send this reply. Uh, so I can't speak English while I'm typing Swedish. Sorry. I could multitask otherwise. With 2 languages, it's too much for my poor brain. I'll have to finish a bit later. Because I want to type more than I want to take down for now. So but now I started it, so I have help next time I open my phone. Please share all of the not of one program. Here's an overview of a computer's memory architecture, highlighting different types of memory and their uses. Yeah, so it has even the registers. Cache. Yeah, so this is not what I wanted. I didn't want types of memory. Uh, I meant only of the, what did it call it? Just RAM. Oh, let's just do RAM and we'll get that. Different section of RAM in the computer, focusing on how it's utilized by the operating system and applications. So we have kernel and user space, and kernel space is purpose used by the operating system kernel for core functions, device drivers, and system level processes. Components, kernel code and data. Contains OS kernel code and essential data structures. I'm assuming for Windows that's like a lot, right? Page tables manage memory mapping between virtual and physical addresses. Yeah. Buffer caches store temporary data. Shared memory too. User space purpose used by user application and the processes running on the system. Components stack measures function calls, local variables, and control flow. Uses automatically draws things with function calls and returns. Operates on a LIFO basis. Heap dynamic memory allocation for variables that persist beyond function calls. Yeah, but not only growth with malloc view. You can have this in functions too. but it will still persist even if you don't free it, right? Delete it. So, okay. Data segment, initialize data, data section, hold global static variables initialized by the program. Um, uh, Initialized data, ESS section, stores global and static variables. Purpose. Yeah, so it didn't get what I meant anyway. Shared memory. Purpose. Allow multiple processes to access the same memory space for internal processes. Communications. System libraries. Applications for efficient data sharing without copying. So, IPC. Um, Memory mapped IO. Maps files or devices directly to RAM, allowing file access as if it were part of memory. Yeah, it didn't really get what I wanted at all. Again, free memory, unused memory. So, no, I meant how it's, let's say physically, physically located on the memory chips. What data, where, how is it organized? Windows, Linux, yes, of course, and I can't even spell Windows. My god, I can't spell physical either. Located. And wind was will have to be there still. Oh, it's still replying to the last question? No? That's a bug. So much a bug. Okay, let's edit it and send it without editing it. I got it. Let's dive into how data is physically organized on RAM chips and how operating systems like Windows and Linux manage the space. Uh, Multiple chips on a DIMM board. Each chip is a grid of memory cells organized in their own columns. Each cell stores. I think it did that very word for word too. Yeah, so I'm more about interested in this, but I couldn't find a better word than physical. Yeah, so I don't need the banks, but actual addresses would be interesting. Also abstracts physical RAM into continued address space using page. Yeah, each process has its own virtual address space mapping to physical RAM by the MMU. Page frames. Physical RAM is divided into fixed size blocks called page frames, commonly 4K each. Page frames are mapped to virtual pages in a process address space. Windows uses hierarchical memory manager, virtual memory manager, allocates memory for sections for process, kernel, and I/O operations. Employs demand paging, only loading necessary pages into RAM. Linux uses similar paging and virtual memory techniques, splits RAM into zones, the main normal high memory for different type of allocations, uses a buddy system for allocation and the slab for managing frequently used state objects. Physical address mapping. The OS and the menu translate virtual addresses to physical ones, optimizing RAM usage. Page can be scattered across different chips, banks, rows, depending on availability. Data placement, program code. So typically, this is like that's probably the words I was looking for, right? How is the data placement, right? Typically placing lower memory segments loaded into specific frames. A stack and heap, then double the manage. Stack grows downwards, heap grows upwards. Kernel data, protected memory regions, often in higher physical memory. Key points. Interleaving data can be spread across multiple banks to maximize speed and bandwidth. Physical mapping, those dynamically assigns physical location, optimizing performance and reducing latency. This physical to logical mapping lowers affect the RAM balance speed, data accessibility. Yeah. Please focus on the data placement and expand. Here's an expanded explanation focuses on how data physically placed on RAM chips and organized by the operating system, especially regarding how Windows and Linux handle data placement. Physical data placement on RAM chips, it's wrong by operating system. Yeah, so maybe I'll just skip the first bit there then. Yeah, so this is like obvious, right? And we also just read it because it was kind of the same thing as said again. Virtual memory and paging. Both Windows and Linux use virtual memory to abstract physical RAM, dividing it into pages, so it's still repeating everything. No, please ignore the physical bit. And only focus on the connection between memory addresses, and I missed a D, I don't care, and OS and program use. Let's focus now on memory addresses are used by the operating system and programs, emphasizing the connection between memory addresses, source management, and how data is organized and addressed. Memory addressing and OS management. Virtual system are both Linux and Windows, and I suppose use virtual memory system where each process has its own virtual address space. This instruction allows programs to believe they have access to a large continuous block of memory regardless of the actual physical RAM size. Address space layout. Each process virtual address space is divided into sections or segments. Each process text segment contains executable code from the program, usually marked as read-only. Data segment holds global and static variables divided into initialized and uninitialized PSS sections. Yeah, so we're like looking at the ASM sections here, right? Text and PSS. Used for dynamic memory allocation, malloc, new. It grows upwards in memory as new stack. Sorry for skipping the end. Should have just not done that and have explained why I did it. Used for function calls. We're just repeating the same over and over, you know. User function calls local variables, managing control flow, it grows downwards as new functions are called. It still didn't say anything about exactly. It's just saying it's divided into segments, right? I'm getting annoyed at it now. So how I should have just gone to some. Should Google instead, right? That was used as management. MAU to map virtual addresses. Again, the same repeating. The same repeating. Okay, so we need a new one. It's stuck. It's stuck on the physical stuff. I shouldn't have mentioned physical. Uh, please explain. Let's do actual just Windows now then. How Windows uh, uses uh, memory. So what data is put on which addresses? Exact example of a possible running computers memory layout based on memory addresses. So can you do that? So I don't care if it's physical or a swap file. I just want to see, yeah, now we're getting somewhere. So from this to this, we have user mode addresses. I don't care which one answers. This one is not good, definitely, right? We'll see if it actually managed to answer using all of the free stuff for today. So user mode addresses used by application. Each process has its own separate address space. Includes heap stack. Now it's actually getting somewhere, right? And loaded modules DLLs. So we have a more detailed one. I don't have to ask for it. And I don't think this is a short answer. Do you think it's a short answer? With short answer, I mean like 4 sentences, maybe? Then I can expand, ask something new about that, right? So remember, short is 4 to 6 sentences, right? I'll have to do that. User mode addresses. Used by application, each process has its own separate address space. Close heap, stack, and load the modules. I read that already. Chrome mode addresses. Used by the operating system. Shared across all processes. Contains kernel code, driver, system caches, etc. Examples of memory layout similar. Let's consider a 32-bit system with the following memory regions. Reserved for hardware. Interrupt vectors. Application stack. User function call. Local variables. Application heap. Dynamic memory allocations. And we could like check what size we're talking about here. Yeah, so this is much bigger. No. 1, 0 to 1 minus 1, 0, 0, 0, x. I'll have to calculate. I can't see it clearly in my head. To B, that's kinda a lot. So it's much more than this. Loaded modules DLLs we have in this section. Libraries required by the application. Mapped files, shared memory files, mapped directly into the process memory. Okay. Kernel and system memory over 8. Kernel code and data structures. And over 9, we have memory mapped IO and hardware drivers. Okay. So it's a simplified. We don't want that. We want the full thing. Detailed example, for example. So please give me the non-simplified version of. Maybe that's why, because I had short. Then it's okay. Here's a more detailed version of the memory layout for a typical 32-bit Windows system, including additional specifics. So, system reserved memory. BIOS hardware resources, system loader data and page tables. Application stack, space allocator for stack of the running application. Includes function call management, local variables, and return addresses. Application heap, determinable by allocated memory for the application. Oh. Sorry. So this doesn't really contain anything more, does it? Shared memory, memory files, space used. Oh, it's the chorizo. Sorry. Includes memory mapped IR for inter-process communication. Yeah, so we have private application data, private memory space for each application process. So may contain data like temporary files or large data buffers. Often used for standard configuration, but may be used for custom drivers additional features. I'll just see if I can. There. Space for system libraries and frameworks used by the OS and applications. Windows libraries, runtime support, kernel space, hardware device servers. large user space versus user mode. Addressable space for user mode applications. Okay. Reserve for large data structure application and dynamic memory. Kernel mode address space. So we'll let you compare these. And also, I would never trust anything here without confirming it. I have had so many hallucinations from AI from LLMs. Yeah. So we have something here. Let's go back to what we were actually going to do here. So push and pop. It said that here too. Why? The push and pop instructions are fundamental x86 instructions used for stack manipulation. They're crucial for saving and restoring data, maintaining function state, and controlling program flow. Here's an detailed explanation of each. The push instruction saves data onto the stack. It decrements a pointer, stack pointer, and stores the specified value on the new type of stack. Decrement stack pointer. The stack pointer is decremented by lots of data being pushed, usually 4 for a 32-bit system. Yeah, so this is what's interesting here, right? Push makes it 6, 32. I think it's probably right, yeah. So we get the same darn documents. I didn't want PDFs. Well, I guess might be good. Oh, I'm curious. This is number 1. I wonder how many we will have downloaded finally. 171. A lot of things seem to be in 161. Arithmetic applications. Yeah, so let's hop down a bit. But this one doesn't have 171 pages. This is some kind of like, oh, here you can read stuff. So what is this really? So if you say a page number, you need to say what book it is. Yes, gubben. På en gång? Nej, det vill jag inte. Du får vänta lite först.
Only waited 7 minutes.
Du kanske vill ha ananaspizza sen idag? Mhm.
I want my blanket to be fixed.
All right. Vi får titta på det sen. Jag jobbar fortfarande. Vänta lite med maten, gubben. Okej.
Panda Tongue says quick someone steal her chair.
So. I heard you, Panda. Hello. I don't switch my mic back, right? So this one, that would be the worst. Venga. Oh. Ah. Yes. Oh, 9 more. Sorry. Vilket läckerben, det kan till stretch. Right, yeah, I forgot to switch back to mic. There. So, let's... Hi, Panda. Yeah, you're welcome to steal my shares, and then I'll just stand up and get a bit more exercise, right? I need some exercise.
Panda Tongue says, haha,
even
hello.
have training clothes on, really. So yeah, so the textbook book, that's like, okay, right, so the information is not here. This is why I asked ChatGPT. Okay, this is why. Oh, this might be interesting. I know I clicked it before, but so though this is not exactly what I wanted, or see. Yeah, so this is not exactly what I want, but whatever. Oh, let's close that one. So stream crashed again yesterday. I had too many things open, too many tabs, like 100 or something. I think I closed 72 though, so it was like 75 tabs or something.
Panda Tongue says, LOL geez.
Yeah, so for Firefox, and I only have 32 gigs of RAM, so it's... And the VM running, stealing 8 of those. And it actually crashed when I did a buffer overflow in the VM. So I'm like,
Panda
that's
Tongue
not
says,
the
I
first
thought I was
time
bad
that
with
happened.
tabs.
Oh, 100 is nothing. I think my kid had like 2,000 tabs. But he started sorting them now. I don't know how many he has open, but also his computer is kind of slow always, even if he hasn't got Firefox running. And I usually have a few hundred tabs. If I don't close them down for some reason like this. Now I put all the tabs just in a tab pair. So I'll open them back up. Today was like 85. So
Panda Tongue says, I love when someone hands me their phone and they have thousands of tabs open in their browser.
Yeah, on your phone you never close tabs, right? Why would you? It just works. Always. The psych pointer is I think I already copied this. Let's actually try and paste it. So where was I actually typing? Was it up there? So this is where we're actually supposed to continue here. But we haven't gotten there yet, we're just working on this instead. And this is good. It's not like I'm wasting time or anything. Really understanding this is great. Yeah, so here we have push and pop. Yeah. And this is why we mode stack frames here. I'm like, ooh, how did the old one look, really? My memory organization thing. I actually had it up on my other screen here because I was looking for what did I lose something, you know? Right? So let's continue. And actually paste this. This won't be the exact right spot probably, but pasting it somewhere. No, let's just let's compare it to the other one. I'm going much too far, I think, here. So this is what the other one looks like. Just instruction. Here I have instruction equals well, this is just for call. I should really use this. This is just spaces because it's so horrible, the Obsidian with this thing. It's just that it's just one here, so here I split it up, and now we have two. So if I were to do like this format, yeah. So let's go. Actually, if I undo and redo, then I will hop to the right place. Why the space here? I don't like spaces in comments like that. It's ugly. And this is not a comment now, so we can just not use tab because it can't handle that spaces. So this is push. I guess colon. Oh, would be pleased whatever I do here, so we may as well just continue. Stack pointer is incremented by the size of the data being pushed. I don't like this description. Decrease. Oh my god. When you're so used to typing things that you do it without thinking. That's not very good. So then store the value of the at the new top of the stack. So the specified value, e.g. a register or an immediate value, is stored at the address pointed to. So we can click copy, I guess. That's annoying.
DR Origenes says stack-based buff.
Yeah. But we're looking at the details. So right now we're looking at what actually does pop and push do. right? So that's what we're doing right now here. And I'm like writing a this is how it works thingy. Store the value at the address point now pointed to by ESP. And then we have pop. And I wrote these kind of things for other instructions, and then I sent it to ChatGPT, and now I asked it to give me the same format for these. So we have it here, the same kind of thing. So I'm just also checking, is this logical? So example, push EAX. ESP is decremented by 4. The value of EAX is stored in the new location of. Yeah. So it, for me to like this, it would have had to have these there too, right? Meaning EAX here. So pop instruction. The pop instruction retrieves data from the stack, loads the value at the top of the stack into the specified location, and then increments the stack pointer. So reversing it, the value of the address pointed to by the stack pointer is moved into the specified register or memory location. So I think I will copy this and change it again. First of all, we don't want that.
Dr. Origenes says https://www.felixcloutier.com/x86/.
Nice. Yeah, I think I've been at this page. But there's some money, right?
Dr. Origenes says it shows you all the operations with some pseudocode.
Yeah. Yeah, but I want to know all the like basic instructions. That's part of it, if you know what I mean. But we could try if let's look for push here, for example. Yeah. So yeah, I've been on these pages. Maybe not exactly the site. It's like there's lots of them. Yeah, so it doesn't have what I'm doing exactly.
Dr. Origenes says it's very useful. I use it every time I have to develop something for Windows kernel XT.
Ah, nice. Yeah, so I'll save this link. Let's see. This is not a lot of stuff here right now. So let's put it here. So I haven't put all of them. Since you use it, I assume it's good. Let's do destination here instead, right? No. I didn't think. I was going to type it here instead. Destination. Push value. Right? What it actually means. There. So move destination, that's very logical. I have it saved, so I'm closing it now. So stack pointer was incremented by the size of the data that was popped. 4 bytes for 32. So, and this is it's bad at commenting. So let's change this. All right, because of the formatting issues there. So will be a lot of more spaces. Obsidian can't do tabs. If I tab here, it does this. So it's a bit annoying. I would like to be able to do tabs. That would be nice. Right, so we need to change this. Let's see. Increase the stack pointer by the size. Doesn't matter if it's like the same. Of the data. So this is, I could have really copied this line, right? Store the value at address. Now pointed to. Load the value at SP into the destination. So, was there anything else here? It's annoying example that doesn't have the explanations. Summary push. Yeah, so let's close it. Right, this page. I should add this one too. Goes kind of nice. It didn't have what I wanted either, but it could be useful. So the Google gave us lots of things I already looked at. So if you open this, it's just references into a book that we don't even know the name of. So it's like the course book.
Dr. Origenes says if you looked at it but is very necessary, highly when you are starting with ASM, to learn about Indianness in memory cause it can be very rare to make sense at first time.
Yeah, but I know, it's a bit of a mess still though, because even when you run like debuggers and look at what's happening in memory, depending on the format you select, it reverses the reversed Indianness. You know, it changes stuff. So I noticed that when I was comparing different outputs. It's in here. Let's see. Maybe one of these. Yeah, it must be R2's different ones. Right, I just had to add it the other day, so it's in here probably.
Dr. Origenes says the best way to learn it is with plates no joke XDDD.
Yeah. So let's see for different output methods. So this is the PXA, and if we do other ones, let's see, PXA. So I might not even have it here. This is PXA again. So I probably learned I like PXA by this point, because it's just PXA. You have all of these written out. That's nice. But I have one somewhere where I compared the different ones. And some of them, when I was reversing it manually, it was wrong because it was already reversed. So it was like, I did remember to do it, but still. Yeah. So it's a bit tricky, especially when your program isn't consistent. Yeah, so we haven't finished this. So what do you usually do? Dr. Originus. Did I say it right? And welcome in.
Dr. Origenes says tell me. Dr. Origenes says yes. Dr.
Yeah.
Origenes says XD.
Yes, I think I have. This is not finished either, but I have Indianness at least somewhere, I think. Maybe? No, this might be somewhere else. Yes, I have so many things in my obsidian. Yeah, but I would have preferred it not to be, reversed, but it's life. So I actually have old memories, like what can it have been when I was in like 6th grade or 7th grade or 7th, I think. Then I had actually machine code in school, and the PCs were not that old then, and we used interrupts to like control the cursor on the screen and stuff. And the assembler too. That was fun. So I'm not totally new to assembler, and also I've done it
Dr.
for tiny
Origenes
processors
says yeah,
and stuff.
that was my first problem with ASM and memory layouts. Then I find out what was calling conventions XD.
Yeah, and for PCs, it's also the Intel and AT&T problem, right? You say, so this goes with this. Oh no, because now we have the funny percents or whatever. So now we're in AT&T land. So, but it seems like you can set any program really to whatever you like, right? That's nice at least. But I'm more used to like tiny processors like PICs and I have this big manuals here somewhere for some kind of more advanced chip. Anyway, reduced instruction sets, kind of much simpler than PCs, right? So guess I should finish this and sort it in actual logical order here. So far we have, this isn't finished either. Also in the middle of typing. The heap is mostly used for, and then I'm splitting up what I had just list with dots. Yeah, that's enough. That's good enough. The stack gets more stuff. A thing, yeah, you need to remember with the stack that it goes downwards. But you're right, I should add endiness to this document. This means that, for example, the space for a new variable is declared the address, so it will be lower than the last one, than the previous one. Nah, let's leave it like that. So the assembler instruction push and pop can be used to quickly add, remove something to from the stack, like a plate on a stack of plates. It sounds so funny when you reuse words, but I guess it's okay. The reason for the new stack. When a function is called, a new stack frame is created on the stack. Yeah, so this is like, I have stack frames already. I just moved it from further down. So, what push and pop actually does. And I guess this should be like a, what's this, 4th, 5th, so this will be 6th level ladder. 1, 2, 3, 4, 5, 6. There. And then I have for
Dr. Origenes says https://github.com/infosecurity/binary auditing training.
so.
Dr. Origenes says this is another resource useful.
Oh, nice. Thank you. The problem with a lot of resources, though, is that I have too many resources. But if something is recommended, that's higher on the list, right? Okay, free IDA Pro binary origin training. Okay. Nice. Yeah. Let's actually copy this so my stuff doesn't crash
Dr.
again, like
Orihina says it tells you how
yesterday.
to decompile ASM by hand.
Nice. Yes, I saw it was started with C++ and then fundamentals. And then HLL mapping, which I don't know what it is. Oh, a lot of EXEs. And the README. Okay, so example of how C++. So we have compiled a few things to test. And I also had problems. I tried to manually use printf in assembler from C, you know. And I didn't know how to do it, so this might be very useful there.
Dr. Orihina says those are all exercises. You have the book in the first folder, I think.
Okay. So, PDF. Alright. Okay, so here's the PDF. Please read me. Thank you. Now you have read. Oh, I love that. That one was nice. That's funny. That's so funny.
Dr. Orihina says the main problem with printf is the calling convention. It storage the input very strange at first.
Yeah, so the problem for me, I guess, is that I don't know all the parts around the actual, you know, there's so much else. If I look at an L file in a, well, disassembler program, there's all these sections, you know, that I don't know what are all these other things doing. My code is here, it's tiny, but there are like a million other things, and the file is like thousands of, I think it was 15,000 bytes for a tiny elf thing that was like C code, like 3 lines or something, you know? And then I'm like, what is all of this? I need to know what all of this is. I don't understand it. What is it?
Dr. Orihina says yeah, for that you have to check out about the compiler. GCC puts a lot of garbage XDD.
Yeah, this is crazy. You know, when I used to, long time ago then, in like 1985-ish, you compiled the com files for it wasn't exes. Exes were when you had a lot big ones, and those files were tiny. I have to Google now. Com vs exe. Com rather than exe. Binary is usually smaller and easier to program using an assembler. Once compilers no longer sufficient power became no longer advantageous to use com. Okie dokie. So how long ago did people stop using them? So I think what year could I have started having programming school? I'm not going to read all of that. So it was just a parenthesis there. So I have a link copied, so let's put it somewhere. Yeah, so we have lots of information here like this. If you have any anything else to add, I'm grateful.
Dr. Orihana says if you want to find out what print really does, you need to locate the CSDD library. There you have the real print code. If you try to just call print, you only gonna see a link.
Yeah, but I didn't want to see what printf does. I just wanted to be able to know how to call it from assembler, not compiling C. So not using, or rather, link it and everything. How would I tell it? Because when I disassemble something, I got something, and I tried to compile that, and it didn't work. That's what the problem was from the start.
Dr. Orihana says in Windows is more simple. I how to do it in Linux. Sorry XD.
Okay. Yeah, so Windows, I can imagine. Yeah, this is more simple. So what I was talking about, that was like
I
DOS
am a Windows internals
4 or
enjoyer
5.
XD.
Yeah. I always use Windows, but I guess Linux. You have Kali, right? So that's what I'm starting with. So also I found this one too, and even if I know already lots of this, it's nice to both to repeat it now when I've been doing it for a few, like I think I did it for more than a week before, and now I want to finish it. Like it's actually in my path in Try Hack Me that I'm doing. There's
Noriko
one called
Neko says
Buffer Overflow. Hi Nori. Welcome back. So yeah, so there's really a path on Try Hack Me. Let's go there.
Dr. Orihana says I'm going to eat. I come later. Bye.
Yeah, you're welcome back later. Thanks for the help. So this is a path I'm doing here. Buffer Overflow Prep is what the room is called, but it requires pre-knowledge that I don't have, so that's why I'm interested in Buffer Overflow. So I want to know all about it and learn all the things you need to know to really understand it, and know all the things and do all the things. I wasn't finished here. I have to finish the last bit. So how are you, Nori? So I want to taste those jelly beers or whatever it is there, especially with the changing colors. So looks tasty. We need some snacks, right? Actually, I have vitamin candies for my kids that are bears.
Noriko Neko says Noriki 1 bop strawberry better.
I could get those vitamins and give you some here in the camera. Though you're only supposed to eat one of the vitamin D
Neko
ones.
says I'm okay. Very tired. Noriki 1 cry.
Oh, very tired. So I hope you sleep good tonight. You streaming today? Friday night. Yeah, so we have the multivitamin bears. You can eat 2 each day. And then there's the D vitamin. You can eat 1 of those. And then I'm like, oh, but 1 more wouldn't hurt with it. So, I hope I'm not poisoning myself by some extra vitamin D sometimes or something. I think you can eat kind of a lot of those.
Noriko Neko says
right?
yes, it's party weekend. Noriki 1 boba.
Yeah, nice. So let's see the link here. I need to put it in some good place. Binary auditing training. Let's make a new node here. Training links, right? And put it here. And then I'll just undo that. And then we'll fix the last bit here. So I think we can really delete this if I don't want it to be complete, which I kind of do. Let's actually put it in between here. so it's all logical and ends up here. So this is connected to the stack. So that's why I'm ending with the stack. And oh my god, maybe I should open the window, it's warm in here. So
Noriko Neko says you coming to party. Is bring your own alcohol plus extra for me Noriki 1 boba.
I don't drink alcohol, sorry Nori. But I could teleport there for sure. For sure.
Noriko Neko says okay bring just me some Noriki 1 boba.
Okay, I'll do that. So the stack is mainly used for. So what did I say before? It's just about the direction, right? It's maybe used for saving. I'm thinking like smaller amounts of data. And I'm thinking primarily, no, I don't want to use that word. The most important being the next instruction. There's
Noriko Neko
details
says
later
adzuck,
here.
need to be on my computer then no add Noriki 1 oof.
Oof. Oh, I'll type in chat here. So hopefully they will be over before I've finished typing. There, the 1 TTS when I dash at the start, I added that to this TTS2. So the stack is mainly used for saving smaller amounts of data. The most important thing being the next instruction. To run after a function is called. The next instruction to run and the stack address to hop to oh, I don't want to go into details here. Run and other registers after a function is called. Local variables. So, and there will be more information. The assembler instructions push and pop can be used to quickly add or remove something from the stack. Add to remove from. like a plate on a stack of plates. The reason for the name stack. What push and pop actually does. And we have push and we have pop. Stack frames. For every function that is run, a new bit of the stack is used. And this is why I didn't want to go into detail here, because it's just here. The whole top of the stack is B will now be the base. Right, I need to add information about on the register bit here. There are also other registers, for example, AX, BX that have specific functions in the execution of a program. Also, an E is added. Or should I just give some examples? Also, the names. Names of the registers are changed or added to with depending on the, we can have it all here on the number of bits. I was going to write processors, but now I'm thinking to program, right?
Noriko Neko says, what is today's thing to do?
Today's thing to do is to continue actually typing down there. Find out how much space we have for shellcode, but I'm just going to finish fixing this first. So I don't think my kids want to watch a movie later though, unfortunately, because I was like, I want to watch the Harry Potter movies again. It was so many years ago and I want to do it with them, so you have to like know that, right? It's basic human knowledge to know a bit about the Harry Potter movies. Oh, let's close that one again. So heap the stack, and then we have right. I learned how to do this. Right, we can compile it to assembler, but it's like special. Registers, data registers. I'm thinking we need a special one for the registers. Right, I don't want this in here. I want this in a special one. So I'm going to cut it. There. Kachuk. And then we do new node registers. And I guess we x86 this. And data array is a type of general registers. Pointers, index. Yeah! What happened with the rest? I'm like, there was more here. What happened to the rest of it? Or wasn't there? Oh look, Here I have exactly push and pop already done. Each function has its own stack frame. This is like when I learned about stack frames. It was definitely less than 2 months ago. That's what I'm thinking, at least. Where each new stack frame is allocated when the function is called and deallocated. Yeah, this is when calling. But nothing more about registers here. So let's put a link here. Heaps, stack frames, registers here. So now we're going to put register x86 and do more about registers. Here. So if we want to know more, we click this and we go there, and we're learning all the things again. And at the start of stream, or rather like after 47 minutes, because I still have this up when I was trying to go like, oh, what did I do? Did I remove something? Well, let's close it. So I'm going to get this thing now. Let's make. It was a long time ago since I updated it. So cd public and get this. We'll see, this will be a long list. Right, seriously, I don't like that. I want to see the whole thing. I want to see the whole thing. So let's cd colon c cd public, and my brain tells me you shouldn't do lsola. You shouldn't do lsola. Dir ls works. So let's just instead do get status. And it's not like a million things that are updated, but we've done SQLi stuff too. So let's do get add. And a few things are skipped because they have their own gets. That's why. So stream broth scripts, I should probably make a commit there too. Well, so git commit updates 2024-09-13. These are nodes, so it's not like something really happened. It's just updates. And then we do another get status to see that it looks good. Ahead of 14 mean by one commit. So we do get push, and they should be the same. They seem to have gone just great. So let's exit that, and let's actually close this. And it's online. In case anyone is interested, the repo is updated. It's available. Let's find out how much space we have for shellcode is the next step. But first, I need to start the VM, 1542. So I'm starting Kali. It's a bit slow. Right, the forensic one. We should see if we can fix that. Maybe someone has tips. Come on, Kelly, you're quick. Show how quick you are. Come on, come on, come on, come on, come on. So I'm on the fourth one, since I usually do VBands there. Yeah, we need a VPN. So let's SH. Yeah, that's the one. Right, so I switched to this one because we want to go here. I didn't have time to finish, so we have the VPN up, and we can SSH here to this. Do we need to click here to spawn? This is the second time I'm doing this, so that's why I'm like slow. So I haven't used HackTheBox Academy before. This is all new to me. But I really want to do some boxes now. And someone talked about it too. Then I really go like, I want to do that too. But I want to finish this, so I'm done. So I know it, so I understand it all. So we have an IP. So let's SSH. And yes, it is this one, HTTP student. And then we have actually the same IP. One of them had previously. Yes, HTTP usually has the same IP for the same box, right? So it's not just random one. HTTP student password. Oh. I'm not typing this. No way. Why have such a long one? It's not like anyone would not know it, right? So Backbone says do this. There. We have bow there. So those are the questions. Submit the address of the EBP. That's the answer. And they'd use GDB. So let's do GDB. Oh my god. Wrong machine. GDB Q for the license information, really, right? Not much more. And see if I can remember. IR. And first we run. What if we just run it? It will crash.
Fixit42 bot says new follower Dr. Origenes. Less than 3.
Thank you for the follow. Thank you for the follow. So I'm trying to remember the commands before I go and look at my notes. But what did they say to do? Nothing special? It's like examine the registers. When we have sent input and it has crashed, or and what input should we send? Is it exactly what we have here? Of course, because if we don't do this, by the way, it was funny. They're creating a file, a text file, with the contents here, the pattern, and then they're using Python to print the string after catting it. So I just did cat here instead of the file, right? So this one will have nothing. But let's experiment and see. I know that you can do some things inside GDB. Can we just ls stuff here? No, because it's special ones. So I'm thinking we can't do... Yeah, we can. So let's run. And let's do $parenthesis. And that's the wrong character. And let's do the folder name of this script. There. No, because we changed it to a specific one after. Whatever. What was the question? What is EBP? Okay. Alright, you're on the wrong screen. Sorry. So let's use this one. Right? I think this is the last one before here. So this is probably what they want us to do. And we have to add parentheses because no, this is their box. We're on their box. So print Python will go to Python 2 probably for this one. And I already have written everything except this. So let's assume that Python goes to Python 2. So, and then that would work. Yeah. So let's do, is it IR? IR. I remember. They didn't have that in there though. I had it in my notes. They had the full name of it, whatever it was. Registers something and it is EBP. Yeah, and I was kind of thinking we don't really run this, do we? If this is the one we want, because it will be 5 5 5 5 5 5 5 5. So I'm not sure if this is what they want because it's too obvious, right? If this is right, I'm like annoyed at it. Oh, I can't click enter. So I didn't have to start it. That's annoying. Okay, I have to understand it or start it. Okay, we're almost at the week goals of having answered 3 questions. Determine the length for shellcode, and this is what we're at in the notes too. And I have, yeah. So I think the only time I looked at this when looking at Alhazred's saved stream on Buffer Overflow. It's a long thing on the Windows too, but it's good. So. Determine length for all he does is good, right? We like his contents a lot. It's good. Now you should find out how much space we have for our shellcode to perform the action we want. It is trendy and useful for us to exploit such a vulnerability to get a reverse shell. First, we have to find out approximately how big our shellcode will be that we will insert. For this we will use them as a fandom. And the HB room, it uses a specific one. This one. We disassembled it to see what it does, and it's very, very basic. And I wrote here what it does. It does bin sh, and it has some extra 11 here, and then it just shifts it out and in. I'm less curious. There will be zeros here then, or what? And why not just do zeros instead of having 2 extra instructions? I don't understand this. So if anyone that knows assembler would tell me, I'm happy. And also this is not Windows, of course. But it has this extra 11 there. And this is R2's nice coloring and everything. Then this RCS is pushed onto the stack, and yeah, so it prepares some stuff for the syscall. What syscall it is? Where is that? Don't I have that in my notes? I don't. My god, do I remember it? Does it say? This is bad. Now we need I had a list of syscalls too. Linux syscall list. Is there a page I've been to? No. So it was 59 decimal. I could see the 3B here and 59 here, so it's converted. Yeah, I should have this in the notes. Execve. And I guess we can click it too. So there. So, and here are the parameters. Execute the program referred to by path name. And we know where that is. It's there on the stack. argv char const nullable nvp. Okay, so args and environment. NVP is an array of pointers to strings. Conventionally, key equals value passed as an environment of the new program. NVP array must be terminated by a null pointer. Okay. Array of pointers to strings. This manual page. No, I hopped arg. I thought there would be a space in between. Argv is an array of pointers to strings passed to the new program as its command line arguments. So we don't need to read more. So I'm tabbing, of course. So where would I see that these So RDX is zeroed out by XORing with the self. Yeah, so I should have made more notes when I looked at that. By the way, I'm seeing an ad apparently. I checked before when I deleted the chat message. That's funny. I'm giving myself money by watching an ad on my stream, am I? Well. Not that it's a lot of money. Yeah, so let's be done with that one, or let's just scroll down. Errors. Examples. Let's. I guess I will learn a bit by bit, right? So that's what I was trying to use for another one. With MSF Venom, it generates these kind of things. And of course, we need to use the full command. I guess we'll copy this. No encoder badgers specified. I put in raw payload, and then they've snipped it out there, so probably so people shouldn't copy it because they can't, right? They're really skipping this bit because generate. Yeah, and I noticed that some people do shellcode as one word and some as two. And I'm kind of used to Swedish where we always put words together when we do this. So I'm trying to be good and not do that. Alright. So they're doing architecture x86 format C shards or what? Platform Linux, port, lhost. Okie dokie. This is not what the other one does. This one just opens. It's not a reverse shell. It's just a sh. Just runs. So that's why it just runs sh, because this is for opens a basing shell. So useful if suid is that, right? Otherwise, it's not useful because we already have a shell when if we use that. Oh my goodness. A reverse shell would be more like useful for more situations, right? So let's run this command, of course, too, right? And let's do it on our machine. And we don't have any port or anything yet. And we would have to rerun this, but let's run it once, I guess. Oh. Linux. Oh, right. It starts like that. I'm like, that's not a path. What am I thinking? So now I'm curious to find 3133. The port number. I don't know where it is. Whatever, we run the command. It seems correct. It's under notes now. But it's not for determining the length. This, I guess, the length of the shellcode we need to fit. Which is something else. We now know that our payload will be about 68 bytes. As a precaution, we should try to take a large range if the shellcode increases due to later specification. Often it can be useful to insert some nodes before a shellcode begins so it can be executed cleanly. Let us briefly summarize what we need for this. So I'm thinking, if I didn't know what this was already, and if I hadn't already written it down in my notes, like right here, right? And explained it yesterday, was it? We wrote that text, I don't remember. Then this room wouldn't be, or this academy thing, it wouldn't be very helpful. Because it doesn't say what this is. It doesn't say why, and yeah, it's not as good as I might have thought it was. We need a total of 1040 bytes to get to the EIP. Here we can use, I'm like 1040, wasn't it with 1039? Here we can use an additional 100 bytes of NOPs. 150 bytes for our shellcode. And this is kind of what I have here already in notes. Using bit. This is from TryHackMe. NOP, number of NOPs, shellcode, random data, number of random data, memory address. Oh my goodness. They're really writing it all out in different lines. Okay. Yeah, I guess they're still doing a buffer. Why not just do NOPs? I don't get it. And they're also putting the shellcode at the end, which I don't see why not to do that, but it would be if we were to like miss. Whatever. Now we can try to find out how much space we have available to insert our shellcode. So run. So this was tested with, no? I'm expecting them to try bigger numbers. So already we going to do something. That's interesting. This is 1040. I guess that we just select a part and do this and listen on our machine. I guess I always use the same part, so I should have changed it when I run it, but it's very easy to run it again, so let's open a new tab. Let's do and see. Oh, right. Oh, even that.
Fixit 42 bot says time to move it, move it. 10 chair setups redeemed.
Hi, Goiku. Now it says the right number, right?
Goaku_ says hi.
Welcome back. So, you're the only one giving me some exercise here. That's nice.
Goaku_ says I'm on a work call but wanted you to exercise today.
Oh, thanks. So I'm doing push-ups. Though, something else would be better to do it on than a chair. If I don't have my hands like this, really, I would be. Scratching the side of the chair. I know. Doing a few extra. So like stopping not from my tummy but from running out of breath from talking too much. So we're going 443 and we just L host. I don't get this, really. What? Why? So why are we doing this? So we're going to listen on the same machine? That's not what I intended to do. So it is still up because it is the same one. And we're already connected. And we're not using this thing. This is nice. And this one apparently has 93 minutes left when we started the page, I guess. How large can our shellcode theoretically become if we count knobs and the shellcode size together? Format. So I got a tummy ache not from the sit-ups but from woman reasons. So I'm just going to. I actually got it last night, but I thought I wouldn't have to today. But whatever. Why have pain when you don't have to, right? When it's such a reason. So I thought the same when I went with my kid to his dentist. But then when I got back, I forgot about it, actually. That's odd. Like up and down. So... So what I'm thinking is, what are they meaning us to do, really? So far we're not supposed to actually use that. We're just supposed to connect and try different lengths. That's all. Because that's what they're doing here, right? They're not actually using the thing. So the shellcode here would be replaced probably next page with the actual payload. So far it doesn't matter what it is, and we won't be listening on anything. We're just testing the length. So why mess with all this? It's just a mess. Well. Okay, let's go there, because we don't need to do anything there yet. So if we do quit, we don't have to. We can just run it again. So instead of 36 now, we do 40. And we run it again. And now we of course have another number in there. Right? We could check the memory. Will it... We haven't checked anything in the memory today. So let's see if I can remember. So we ended up doing it in R2 because it's prettier. The output here is ugly, but it's X, right? X, like 100. There you could do X, right? Nothing. Yeah, it's too slow. And I'm going to check my notes because it's still confusing even with the notes. I don't think my notes are complete here. $. So this is longer than this anyway. It's anyway longer. We can do 100. So but it's $. So minus 100. Let's see what this looks like. So we just added 4, right? So if we were to do instead this times 8, it would be the same thing. So let's just for fun do that. So we do this times 8 and this times 36 as it would be before. We run it. Yes, we want to restart. Now we get 6666666.
Dr. Origenes says with GF you can improve the performance of GDB and it's more fun to use.
Yeah.
Dr. Origenes says https://github.com/hugsy/gf.
So I think R2 is much prettier and seems better and seems to be like next generation. It's newer. So now we have a bunch extra of 6 there. I wonder how much more we could. They wanted just to check the length, right? So I guess we will check adding stuff and see what happens. How much we can add. Just a second. I have R2 here too. R2D2 instead. And it's I don't know if the syntax is nicer. It's prettier. I think I had some pretty output somewhere. So we have, this is R2 output. This image. This is R2 PDF for disassembling. But what do you think is the best to use? Because this, I'm using GDB now because they are in this one. But yesterday we did both just to see. We had this better looking at memory thingy there. Let's click your link first. So, oh, I have to middle click or it will open it in OBS. GDB enhanced features. Yeah, and also this is on a box, you know, it's not on my machine, so we use what we have. Jeff. To assess, exploit developers and reverse engineers using old school GDB. Additional features. Yeah, so R2, it has, when you look at the help for it, it's crazy. So first, let's see, scroll down to help. So first, this is just the normal help, but when you do question mark, I just tested and I found it, the question mark. And then it was like, okay, all of these are question marks behind them. I will try a question mark. And then I go like, okay. We do one of those. Okay, and these are question marks too. It's like, okay, how many commands are there? What should I do? Can I search for? I don't know if I can search for any of this. So we were trying to find printing stuff, and finally I found stuff, you know, and it's kind of fun to just find it like this. But
Dr.
still.
Origenes says I'm going to Radar 2 Con this November XDDD.
Oh, cool. So there's so many commands. Do they have like a long list of them all somewhere, so you don't have to like try and think what could it possibly be at the start, so that I can see, put a question mark after and see how it works? So I could like do it all with lots of question marks, but there must be a nicer list.
Dr. Origenes says Radar has a very good documentation to read about it.
Yeah, you see I have a cheat sheet and docs here. It's just that, you know, I prefer exploring it just. So I guess I could like click the docs and search in the docs. Right? We could do that. So what do you work with? What do you do?
Dr. Origenes says, and if you don't understand something, you just tell Pancake and he will look how to improve it XD.
Okay, so that's a developer then doing it. I should look here now, of course. Yeah. What else do I have here? Yeah, and it's pre-installed. In Kali, so I already had it. So we can actually see if this one has R22. Every time I say R2 and something, it's become something else. I think this one probably has R2. Not found.
Dr. Origenes says I'm currently working as pentester, but I prefer Windows kernel reversing and rootkit development, just a nerdy and low-level SHTXD.
Yeah, but that sounds fun. You know, it's not like I'm doing this because I hate low-level stuff, right? I think it's fun. So I'm surprised the Try Hack Me one had R22. And this one didn't. So anyway, let's just start this again, I guess, and let's do something crazy. And so I'll just copy whatever we started with there. That's easiest. So yeah, let's do the last one. My God, scrolling is here. Yeah, right. So we just added that. And if I type something, we will hop down. And let's do times 100. 100, 1,000. So we still get the same thing, right? So how do I know when it's too much? I'm still getting the same error. Okay, I'm going crazy here. So, what do they want? What do they want? What answer do they want, really? Right? So we're just overriding a lot of stuff in this. Nix buff 32. So I'm really thinking the easiest way just to type something is this. So 1, 2, 3, 4, 5, 6.
Dr. Origenes says probably you are overriding too much memory.
Yeah, but shouldn't it like crash more if I'm overwriting all the memory like this? This is so much memory. I was on 10,000 there. So let's go back to 2,000. And we get some 5s there. Segmentation fault. So the default here was 1040, right? And this is what they've told us to do, and then they wanted us to check how much it can do. So if I were to add 1 more, like let's add 4 more then, I guess, because otherwise it's just odd. Indeed odd. So if I do a real crazy number like 100,000 bytes, will there be a difference? No. I don't think this is the thing. Should I make a script that just tests it 1,000,000 times? I mean, if we just run this, let's quit this again. So we have bow there. If we run bow, And then we have the whole darn thing there. And we remove the run. Oh my god. It's slow. It's lagging. So if I run this, a little tiny dot was
Dr.
forgotten.
Origenes says probably you just need to locate the ret and set some memory address instead, just overwriting it. Dr. Origenes says I'm not very good at exploiting.
Yeah, so right now the task is to see how many bytes we can write. And it might just be a math task, right? They might not. The last one I could have just answered without doing anything. No, I'm saving that one. Let's check that later. So if we go and look here, what's the actual question? It is, how large can our shellcode theoretically, okay, so not testing, it says theoretically actually become, if we count knobs and the shellcode size together. Okay, so they didn't want, what? This annoys me. Why do they have these things here and then we're not supposed to test it? I wanted to die and not being able to handle more characters, right? There's nothing in this box, it's just empty, right? So there's nothing in the memory to write. Okay. Well, so how do I get rid of all of this extra stuff here? Terminate. Pwn box. But it's okay to switch location, right? Yeah, so this is why we have D. I'm in Sweden. So Germany is closer. So this is all for nothing, and the only thing, there's a target and everything here, and then we're going to calculate how theoretically this annoys me, okay? So we should count knobs and shellcode size together, and we kind of just had it right here, right? And they've already made nice calculations for her, right? So they're currently doing knobs here and they're doing shellcode here, but why don't they count this bit? So do we want us to add these? It's just odd. So I'm thinking more like adding these together, right? That's more logical. So let's start with 250 because that's less math. So 250 bytes. If this is right, I'm angry. And I have to click to submit. You can't just enter it. I'm currently officially angry. This doesn't have anything to do with real life or even their things, because they've just added 786 buffer characters 55 first. So they could really be this long, right? So don't like it. So this will not get any love from here. I guess it means to toggle to do. Not that we like it. There's no like. So maybe this is very old or something. Well. And I was like, oh, let's do this now. They didn't really, that was nothing useful at all in that section, the last one, because it didn't really do anything. Bad. So my section there will be empty for a bit more. Identification of bad characters. Previously in Linux, like operating system, binary started with 2 bytes containing a magic number that determines a file type. In the beginning, this was used to identify object files for different platforms. Gradually, this concept was transferred to other files, and now almost every file contains a magic number. Such reserved characters also exist in application, but they do not always occur and are not still the same. So they're trying to make a connection between magic numbers and bad characters. That's a bit odd to me. Couldn't they just say, oh, the values, the bytes have meaning? Such reserved characters also exist in application, but they do not always occur and are not still the same. These reserved characters, also known as bad characters, can vary, but often we will see characters like this. Null byte line feed, character return form feed. And these are interesting, and these we will actually copy. And we will make a section in our notes about bad characters. But if I had not already seen Al's video, I would have probably been confused here and thought they meant something with magic numbers. Right? So they just whatever. It could be a tiny connection. But not really, right? It's usually, this is like input. It's not like it thinks it's a file. Back to notes. Let's go to buffer overflow and let's leave this empty. Rather where it is here. We'll leave this empty, and then we will go for the bad characters. So find bad characters. There. This is just shortcodes. So I'm thinking, don't people know character codes, ASCII? Don't people usually know that? If they were like reading a HackTheBox Academy thing? Maybe not. Maybe that's why they're like connecting it here. Because they might have edited magic numbers for something. I'm just trying to understand them. Here we use the following character list to find out all characters we have to consider to avoid when generating our shellcode. Character list. So it's kind of cute that it always puts your name here. That's cute. But I don't mean I have to like it. Maybe. It's cute when it's someone else's. When it's mine, it's just like odd. To calculate the number of bytes in our recursive variable, we can use bash. By replacing the x, what space and so what? Deep breath. So they write all the characters possible in a list. It's not like... It's just everything from 00 to FF. And then they count them. This complicated way to find that there are 256. I'm not following along with their thought train. It's really not. What? Now let's have a look at the whole main function, because if we execute it now, the program will crash without giving us the possibility to follow what happens in the memory. So we will set a breakpoint at the corresponding function so that execution stops at this point, and we can analyze the memory content. Bowfunc function. Alright, we have the code for this, right? Did I actually make this like an example file? We have example here. Yeah, this is the Bowfunc example. So HackTheBox Academy and the name of this, an example. So we've already looked at this long ago. Long ago. Ooh, but on our machine, right? So yeah, they added the comment. It's not automatically put there. Yeah, they did this as too. This we added from our notes there. I'm kinda sure I did. Yeah, this as. Also, I hope my tummy will feel better. Let's eat some bread. So my yogurt is out. I would love to have some yogurt to dip this in, but I guess it's time for Friday night dinner soon. So let's just eat a ton of bread to make my tummy happy. So, to set the breakpoint, we give the command break with a corresponding function name. And confirm we have this break function name, or B, to add a breakpoint. So, they run it. The stack. They do the X slash. Plus 500. So there the 55s begin. With char start. We can see where our 55 ends and the chars begin. Right, so now this is a bit more interesting, really. We'll see that it starts with 1 instead of 0. We've already seen a warning during execution that the null byte in our input was ignored. Okay. Oh. Ignore null byte in input. Okay. Yeah, so now I like this. Now we're getting somewhere here. But it just skipped the last bit. That's annoying to me. So I need to find another source of information. We can do that. So, where was I really? Yeah, so we can note this character, remove it from our variable cars, and adjust the number of our 55s. Without null byte. So I'm assuming they will see what characters are not there. So the program being debugged started already. And then we have 1, 2, 3, 4, 5, 6, 7, 8. Oh. So there's no A. And there's no 9. This tells us that the characters is not allowed here and must be removed accordingly. I need to switch ears. So we're at 4 hours already. So I use these a bit before stream, that's why it's early. Yeah, so this is what I recognize from Al's stream. Let's actually get that one up, and let's do a so YouTube buffer overflow. Oh my god, how does he spell it? I'll have to know the spelling. There's a lot of other ones. Oh, whatever. Oh my goodness. So I should be subscribing. Look, it was in the top of the list. So if we go to videos and we do, well, this is not my normal YouTube, so that's why it's not a lot there. So let's do buffer overflow. This is Windows. So
just I eventually just.
So he's like doing this somewhere here, determining bad characters. So, but he's actually explaining stuff. Not just a lot of things is like do this, do that, and then they don't say what you're doing, and that's what I want, you know. Not just an instruction of how to bake a cake, but why we put the ingredients in there. Now we can spell it. Okay, I should remember this for next time. So, of course we do a shout out, right? Why wouldn't we? So if you're not, you have to follow him on Twitch. So he's been very busy lately with work, so he hasn't been streaming a lot. But as soon as he will, I will hop there. Yeah, so this is great. It's also 4 hours long. So of course there's lots of like chat and stuff, but he has like a PowerPoint course at the start, and then he's like explaining everything carefully. I don't know if I've even seen the end, did I? Yeah, probably. But I saw it. I've seen it, most of it at work, I think, so I wasn't like 100% focused, but I've seen bits of it, maybe half at home. So, determining, let's see, building a simple Python fossil, analyzing vol, offset of return address, overwrite. Right, finding jump ESP address. Right, he did that because that's how this is a FTP program for Windows that is War FTP. There it is, an old one. So I recognize this thing. So there's just like, oh, now we just stop. Must be repeated until all characters that could interrupt the flow are removed. And then there's like login information again. Well, there's 54 minutes. Find all bad characters. So did they start, how did they make the list? Now I'm curious. They counted it. Character list. To calculate the number of bytes. I'm like, didn't they make this with a script or something? We can just copy the list. We don't have to generate one. It's just funny. Funny. So, all 256. Well, I'm doing all 250 chars, you know, because this is all the 2 hex digit possibilities. Let's type that. Because that's what it is. right? Oh my. Yeah, so undo, undo, paste. Right, so let's actually do this then. But we don't want the shell session. We want this. So, oh, look at the last F. There's a space in between. Well, don't ask me why. Obsidian will have to answer for that bug. We need to find out if all characters, if all bytes are acceptable input. We can probably assume that null will terminate the string, right? Probably. So I closed the bread bag with this, and now it just fell off. That's a good closing of the bag. So, to do this, we will. So, what have we done before? Yeah. We've done non-repeating input. We have checks the length to the instruction pointer. And here, find by the characters. We need to find out if all bytes are acceptable input. To do this, we will send all characters along with the input. And then we just add. We can copy theirs. To me, that's not pretty. Let's see, did we have the 6xs? Yeah, we have it here. So this line is here. So now we know what we're doing. 1036. And let's paste it here. Run python c print. And we need a parenthesis. Okay, so they're using O. So am I in the right place? So this one. So to me it's so backwards to have these in here and those on the outside. Yeah, I want it like this. Now I'm curious why. Should we unsnip it or should we let it be snipped? Let's actually snip a bit more rather, so we can see the whole line in one line. Actually, let's do 3 on both sides. Well, then we look in memory. If all characters are there, and oh, I had a tinier bit of bread. Also 2000. Isn't that a bit much even? Mm. 1040, not hex. Decimal. And then they do 2000 hex. Isn't it? I'm kind of sure. Oh gosh. There. Observe. We have to break program execution. So where will we do it though? I don't remember the code. I have to look. So it's the argument, so it should be there from the start. But they did the start of Bowfunk. Why? Did they step anything? They had the breakpoint. And they run it. And it hops to the breakpoint. And then they do this. So this air was not as comfortable. So, GDB break was the thing. No, just B. Let's check. We need to learn the short ones, right? So B, we could also use a test C colon 10, but I'm assuming this requires we compiled information into there, which I think we did in this example. Yeah, B. Bow funk. Okay. At 551. So let's go to our notes. And let's actually make this line, because we need all of them. I'm almost skipping null, but whatever. So let's see if it spaces this one too. When we unselect, no. So I probably could fix this one by putting a space here then. No. Now I'm curious. If I add a character here, it's still there. What if I add a space here? Yeah, whatever. Why does it think I want a space?
Stare_DK says print hello, world
Hi.
!N.
Welcome in. So let's copy this one too. So I'm almost removing null, but whatever. Let's test everything. Of course I didn't switch to this screen.
Stare_DK says \XFF isn't form feed. Form feed is \X0C.
Yeah, so I'm sure there are. This is like an odd HackTheBox Academy thing, and that's what they said. So I'd have to check it out if it's really correct, because they're saying like, oh, talk about magic bites, and then it's like, such refers characters also exists in applications. And I'm like, okay, you're connecting magic numbers to bad characters in payloads. Why? How? I don't get the logic. There was something else there. It's a bit funny. So I'm not surprised if there's errors. I don't remember. Yeah, so form feed, yeah. Yeah, now I remember what form feed is. That's 0C, right? They probably had like several FFs here, and then they added the numbers and they forgot the one because it's actually FF. I don't know. Or is it FF2 in some ASCII version or something? I don't know. Or they just shorted it to FF. Oh, this was fun too. They count the number of characters between 00 and FF by doing this. This was really funny. So how did they generate this? I'm not going to like mock them. I'm doing it, right? So I'm not friends with HTB Academy yet.
Stare_DK says by hand. Mock
Yeah.
derp.
So backwards, everything backwards, probably. So anyway, they have shown her. Oh, it was null. We found null. So next character. So this is good. But I've seen Elle's video, which is much better, right? So let's see. Yeah, so here's where we can see that it's not 09 here. So, and then suddenly, without any more explanations, just process must be repeated, and then we have this. So, at least I realized I don't have to start this thing, I can just SSH here. It's a tiny line just before the question, instead of a mega big thing here. So let's look at memory then. So let's see if their command is good. So is p plus 500 and 2000 when we have, yeah, that's also like 2000 when we have 1024 decimal, no, 1040 decimal things. Yeah, and I don't really know how this works. XB. Hex bytes, I would guess from the output, right? In hex and 1 byte separated. Let's there. So we have 1. First, let's go up, because we will have said ignored null byte in input, or we wouldn't have seen that, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, and no 9. And instead we have termination of the string there. But we still have BCD. That's interesting, really, right? Let's quit the output. We don't need more. And that was like 3 pages. I think they just put a crazy high number. And they don't really know the difference between decimal and hex. I don't know, they must do. Whatever, let's arrow up here. It's so slow, so I think I didn't have it selected. So, oh my, it's slow. How is it that I hop to the start? Right, so we really don't need the 555, so this is just messy, right? So, make it easier for ourselves, and let's just do these. Right, a few ones could be nice to have. So, like 8. So it's a line of them, so we can see it easily. And then a \s x55. Let's do 16. And we start from the beginning, we get to the breakpoint, we'll list this. Now we have 2 nice lines of 5s here. And then we start with 1, 2, 3, 4, 5, 6, 7, 8. And I didn't skip the 9. So let's do Q. And I should have hopped the 9. So what is the command to hop to the start of the line? I should remember it. So let's remove 9. There. Start from beginning, yes. Look at memory. 8. So it also didn't. It also is the same output. Yeah. What's 9 really? Is it the A that it reacts to? Oh, let's do Q. Oh, well. Can I do stuff now? Yeah. Good. So, let's remove A. So, time to go to the notes and check Linux. I have like tricks or something. Maybe it's basics. No, that's like Linux basics. So, go to start of line, Control A. So, Control A. It's much easier to go from there, right? When we have this long thing. So, apparently 256 times 4, right? We don't need a script for that. So breakpoint. So eight B C D E F. So 1 line, 1A, B C D E F, 0 0. So 2 0 hex is also not there. So I guess we will have to do it again. And I guess I should type these in my notes. So I'm undoing my changes here because I didn't want that line. I could just have deleted it.
Stare_DK says I don't have any space either. Moplul.
Okay. Oh. So let's do it easier. There, right? Hex. Write down found characters. Yeah, I'll have to write what we do into. There will be characters missing in memory. Remove one at a time from the start and write them down. Then repeat. Until you have found all characters. There. And this is how far we've come. I will. Was not a nice sentence. I'll fix it later. So click Q. So after 1F it is 2 0, not 0 0 X. So Control A and I'm double checking here. 1F. Scroll. So and now we have 1F, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 2 7, 2 8, 2 9. 2 A B C D E F 3 0 1 2 3 4 5 6 7 8 9 A B C D E F 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And we can really see a pattern here that these are connected, these are connected, these are connected. 8, 9. And then we have AF, BF. So let's make a new line here. CF, DF, EF, FF. So it seems that was all of them. Though I guess I should check so it's not a null somewhere in here. Right, so how far did I really come? Let's just quickly check it to down here. So nothing there, nothing here, nothing there. I would have seen them at once, I think, when I selected it like this too. Let's check the bit up here too. Yeah, I think that's all. So that means the last one here was here. So here we don't have 1F. Because there is a missing one. 2, 0 is missing. So here it's not correct, here it is correct. All the way down. Okie dokie. So let's give them an answer and see what format they want first. So they want \x. Of course, very logical. I was just lazy typing. Deleted the wrong character. So Control V, delete carefully. Will it want a capital A here maybe? And also let's do that so we don't miss the characters. So, okie dokie, it was correct. We didn't miss any nulls. So now I'm curious what they want us to do now. So they already said this, and I was like almost going to try it, but I was like, wait, why did they have L port and 127? So I was like, what are their instructions? And then I saw, oh, we're supposed to do this and this and this. So we'll see. Let's read it. Generating shellcode. We already got to know the tool MSF Venom, with which we generated our shellcode approximate length. Now we can okay, right. Now we can use this tool again to generate the actual shellcode, which makes the CPU of our target system execute the commands we want to have. But before we generate our shellcode, we will have to make sure that the individual components and properties match our target system. Therefore, we have to pay attention to the following areas: architecture, platform, bad characters. So, yeah, so when we run this command last, we didn't have the bad characters, of course. So, some Venom, shell arrest TCP, lhost rport. Yeah, so lhost, right. Yeah, I still need to know what they write. So bad chars, and out file name. So let's hop over to the notes. And here I have the previous one. So this is try HackMe's. Here, if you have seaweed, just a shell. Yeah, I showed it not that long ago. So I'm like, should I copy this? Or will I regret it? Oh gosh, it annoys me, this prompt. I thought it was cute the first time I saw it when it was on someone else's computer. Now I'm like, I guess cringe is a word, right? So let's see. Image of when. So we probably, if we didn't have the answer, we could have hopped to the next page and looked. Is it like that? Now I'm curious. So now that we have our shell code, so I need to know how they're using this next, because the lhost IP there and the port, we need to know what they're doing before we can add stuff. Now that we have a shell code, we adjust it to have only one string. And then we can adapt and submit our simple exploit again. What? What did they say? Oh, right, they do this calculation all the time. Or whatever you want to call it. It's like, for me, I read this as setting variables, right? And what's that? Sorry, no complaining. Grateful that this is a free resource. So, run. Next, check the first place, match the bytes. So, submit the size of the stack space after overwriting. Size of the stack space. I guess we'll just run it. We don't really want it to do anything, really. I'm like, when's the fun bit coming? Okay, let's do... We can really take theirs. It's not like we're going to change the port or the IP, right? So, though they're snapping it. So that we should run it ourselves, I guess. Oops. So let's delete this one. Oops. Lots of oopsies now. So I guess better do it all on here. So why did that edge? Whatever. Well, not mega surprised. It doesn't remember right. I'm trying to remember the name of the function. I have it right here, so bow func. So So I'm actually going to check back the what the question is, so I don't do the same thing again and run stuff when they're just meaning us to like do mega simple math, right? Like 100 plus 150. Submit the size of the stack space after overwriting the EIP as the answer. Right, that was the question. So that kind of makes me think I shouldn't have added the breakpoint. So, let's... Alright, it makes it into this format. I guess that's friendly. But why did we do format C? Why did they do format C? So now we need to know a better way to do this. So MSF Venom. This is like odd things in this one, right? Hello! Yes, we're learning buffer overflow. And right now I realize that it's outputting it as I would write it in C code, but I would just want it in a one string. So I'm going to see if we can get some help on the output format. So it says format C here, and then there's probably other formats. So use list formats to list. So let's do list formats, and these are valid. and it says formats here. So what's wrong with my poor computer? Formats, ist. Okay, let's just do L because it's seeing ist as the thing. So I'm kind of thinking C might be the default. Raw maybe? But I'm curious now what will happen if we just remove it. Let's remove format C and see what we get. So again, we need to cat the file. Yeah. So this might be the raw format, right? And we actually want it as hex. Let's do hex. Hex exists. Hex exists. So let's do hex. We want hex format, thank you. Right. So I almost assumed this. There's bash. There's so many. So what is sh? We're learning here, no hurry. So what if we do sh? Yeah, so it's kind of the same. Export buff. Yeah, so maybe C is the best one. When we test this, we don't want an out file. We don't ever want that, really. So just see if this works good. And far to the list now. See, I really wanted it in like C format, but I wanted to be in one line. I guess. Yeah, I've worked as an IT specialist and programmer, and now I'm like learning hacking and stuff. Yeah. Yeah, I'm a good girl. I won't ever hack anyone. That's why I'm not learning this until now, and you can do it on these safe testing places, right? Because I don't want to do anything bad to anyone. So, let's go back to format C, and maybe I'll test all of the formats someday. But I have tested here. I think you were on the other screen. We got this format. I was like, let's see, this is not perfect. So there's formats, so we can list them here. And I tested a lot of them. I tested am I blind? Anyway, yeah, right, this is without the format well, now I think this is probably the raw format. And then I did format hex. Then we got hex, but we don't have the \x's, right? And then we tested sh format. We get the \x's, but we get still a lot of lines, right? So I just wanted those in C format on one line. So we're back to C. So I'll have to edit it myself. It's not like it's even worth doing something more complicated either. There. So my shoulder started hurting, and I noticed it's almost 18 too. So my hubby will probably call soon for dinner plans. I want to finish this. My shoulder got real painful though. I've probably been sitting in some bad way. That sounded odd. So let's actually keep this full output as an example here of generate, right? So now we want this full thing, pretty output, and then I'm going to take a copy of this for our test. So oh gosh. There, I think it's all one now. So manual conversion. How annoying, right? Yeah. I'm just checking that we have all the steps. Yeah, just short here for using generate example, and here we have written about this. So let's just hop to the end, and I might move this later. Running. I'll change the name later. So first of all, we have this. Why does it hop? I don't get it. It's ugly. Well, OBS and its quirks, I guess, will survive. I'm just going to get the rest of it. Really, we could use what we had a minute ago, right? So where am I typing? Not there. Might we be disconnected from this? Yeah, it's despawned. I had to spawn it again, but I think it's the same IP. That's always nice. That's one thing I like with HackTheBox, is that the box, if you have to restart it, has the same IP. Try HackMe doesn't have that. But on the other hand, your IP is the same, right? Is it on? I don't remember. So I think it's changed anyway for me now. So, Pankura, are you learning hacking too?
VR_mechatronics says I'm going for tests on Monday because I think depression is taking over me.
Oh, that's not good, VR. But great that you're going for tests, right? So, that's great. But I hope you're feeling better soon. Yeah, I know your situation, wanting to study and not being like allowed to, right? Because you're in the wrong country. Okay. Yeah. I'm talking to one person on Twitch and one on YouTube, so you can't see each other's chat. So Pankura, okay. So no or yes? No with a smiley blinking and sticking his tongue out. That kind of is a yes, right? Yeah, and VR, yeah. Tell me if there is anything I can do. Okay, yeah. You're in the Discord, right? Can always talk a bit if you wanna. So, but not in Danish. Because I don't know Danish.
Vscrew_PL says hello, Pankura here, D.
Hi there. Oh, are you Polish? Because VR is. That would be funny. Welcome into Twitch. Now you don't have to wait 20 seconds to hear what I say. That's about the delay difference. So like 2 seconds to Twitch and 22 to YouTube, something like that. Rough estimate. Right, so what am I really waiting for?
Vscrew_PL says yep, ha.
Yeah, cool. So, let's see here. Of course we need to, this is just frozen. It's totally frozen. So let's open a new tab and let's SSH again. And we do have a new IP this time. So it's 51.162. That's funny because I had the same one when we started that I had yesterday, the same IP. But as you can see, it's a new one now. And the password, it's not secret, right? So why have such a long one that I need to copy it? So there. So I was like, oh, we can just use whatever I have in the history. Nah, it shouldn't be that easy. So I apparently didn't click where I thought I clicked. Yeah, so it's seriously easier to get it from the page, right? Yeah, this is a calculation. But before this, what did we do? Right, the Python print without parentheses. Okay, yeah. I think we can close that one tab down, but let's keep it for now. So GDB, And Q for quiet.
VR
just
underscore
getting rid of the
mechatronics says at
license.
bscrew underscore pl, what is it? Pancora.
It's the name from YouTube. Their YouTube username. That's Pancura. So.
bscrew underscore pl says Mr. Chicken. Translation.
Ah, okay. Cool. So, a bowl. I was going to write there. And let's not
bscrew underscore pl says it's my Nick Lamau.
Yeah, nice. So I'm the TTS I usually have, I can translate and stuff. Would have been fun to see if it translated the neck. Sometimes it did. Like people with Chinese names or something, it would translate the names. Play with the robot arm. Is this ARB? Oh, let's finish this first, okay? We have the robot arm here. So now you have the redeems too. The robot arm is right here. I'm just going to, I need to set up cameras and stuff. So let's run this command and finish this one, and then it's like Friday playtime, right? I was like, what am I doing? I'm actually going lazy here, and I'm not typing this myself. So they have 95 characters. Let's confirm that, or let's maybe not, because I'm tired. So by the way, we're not really doing anything yet. So this still can't run, right? Yeah. Oh well. Yeah, let's just there's so many steps that don't do anything that I'm getting bored. Can't they just do one more step and we can actually do something? Just one more step. So
Stare underscore DK says have a good rest of stream, at Fixit42 in chat. See you all la dare.
Yeah, see you too later, and happy Friday evening and everything, if I don't see you before. So bye-bye. So I'm feeling I'm really slowing down, so it's good to end on with something fun there, because I really need to end later. Because my kids will want to do fun stuff, right? Hopefully. Let's see if I can persuade them to see some fun movie or something at least. And then we're going to switch to this one instead, and let's copy it here, and I'm going to check the length of it up there when we have it organized instead. But I'm kind of assuming the same length, but let's check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14, meaning, so now I have to do math too. 14, 28. Nah, I'm too lazy. It's Friday. We're getting the calculator. So 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13. No, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14. Oh, it's 15. 15 is much easier to count with, right? So then we have 30, 60, 90. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 101. Okay. So since we need the length of it, so 1 chars. And did I scroll down? So I'm like 2024 minus. So what is the 95? Yeah, so the NOPs are 124. So that's what I wanted to check. So the 95 is the one we are going to replace. I thought so, but there. Knobs, shellcode, and our very not an address, but supposed to be where the address is supposed to be. Apparently. Oh, that's my lunch plate that I kicked away. It didn't break, at least yet. We'll see if someone steps on it. So. Let's just copy it. I feel really I'm slow now, right? So, soon robot time. So let's just paste this. And
VR_mechatronics says XD.
We have a segmentation fault, and we have the wrong thing, and puts at poles. So let's look at the memory again. So it's supposed to be, if it's the right length. So let's just make sure I calculated this correctly. So first of all, we have 55s, the number that this calculation gives us. Then we have NOPs, hex 90s, 124, for some reason. And then we have this, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20. So to here we have 20. Then we have 1, 2, 3, 4, 5, 6, 7. So 60, 74, 81. I'm just 74 plus 7 is 81, 82, 83, 84, 85, 86, 87, 89, 90, 91, 92, 93, 94, 95, 96. That's 96. That's not 101. So, yeah, so I'm not supposed to count anything else. So 96. So I counted 5 wrong before. Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Bscrew_PL says have good day. You are very nice. I'll come back here someday, Tung B.
Yeah, do that. Welcome back. Don't you want to see the robot? Is it boring? I'll put the robot on in just a sec, okay? If you have time to wait. So you can pick stuff up with it when it's on. Where's the cord? I'll need to move a few things on my desk too and put up a camera or two so you can see it too when you control it. Otherwise it will be kind of hard to do it. There, let's just copy this one again. And so here, Now we have 1 off. So it was 95 still. So I shouldn't have changed it. So this is why we do this, right? Testing stuff. But Friday night at 18 is not the right place to count these, apparently. Yes. And now we have the right address at where we're going to put the address later, right? So now, when we have run it as we're supposed to, now let's check memory. So let's do X. Yes? Jag kommer snart gubben, okay? I don't know if it's something in time. Är det bråttom med något, Lobban? Har du bråttom? Okej, jag fixar det snart. Jag är nästan klar. So we wanted some food, but he ran to the door and knocked. So I was like, maybe I need to check if it's in a hurry. So X600 XB. That's cute that it made that tiny. And was it dollar? I'm assuming it is P. And this was not very helpful. So, oh, now I know, minus 500, otherwise it won't work. So now we have a lot of 55s, and then the 55s end, we have a lot of 90s, right? And after them we have let's see here, BDCA92. Yeah, so here we have the payload until here, where we have the 66s. So everything from here to here, and this is also executable, but this is the shellcode. Nice. So it's robot time if you still want it. So did you leave? Let's see, where is it? Beast Crew PL, did you leave? We can do the robot anyway. I'm just very into this now. It's very fun. Can't stop. Afterwards, we confirm that it's been entered into memory in the format we supplied with Python. Right, Python is great here. It's very easy, nice, very nice. So now I'm almost going to copy the whole thing. Let's do it. Let's actually not do it. Let's remove this line. So we have all the, what was it, 124 for some reason, knobs. And we end up with these at the end. There. So now I'm going to see, I have these in the way. Oh, cables. They were on top of a hard drive, so it's very warm. There. So, oh my god, that hard drive is warm. Warm is not the right word either. Hot. So, I should also have some kind of thick cables there. Let's just short circuit something. So, thing to pick up. Tablet drawer. So, messy desk. Unfortunately. So, and let's get the cameras out with some light too. And let's turn on the app that makes you see. Let's see here. Arian is what I use. Come on, Arian. I guess the easiest thing is to actually stand. So this was used so now you'll see my desk there. Yeah, and these were the tummy ache. Hopefully fix it. Yeah, it's actually gone. It's just that week of the month. Or that day of the month. Hopefully. So, let's get some robot control instructions. Let's get some power for the robot, or it won't move far. So there you go. Oh, you can play with it. Hello gubben! Jo men det är bra. Typ. Han var såhär, pizza. pizzan åt Pelle. Han åt det är 4 måltider för honom. Right, so we're going to order pizza for dinner. So I was just checking what people want. Let's see. So I'm thinking, like, should I remove the robot again? The instructions are kind of easy. You can open the claw. Let's see. Open 30. No, where am I typing? Here. Exclamation O 30. And it will open 30. Right? So you can steer it to where you want. And I need to order pizza. Then I can give you another camera angle there, if you want to. Or I'll just continue a bit with this before pizza gets here. Oh. I have to just check something. I got a message. LinkedIn message. Let's see. Oh my god, I can't. So someone wants me to send them my CV. I'll do that in a bit. So they just sent it at like 20 minutes ago. So I should probably do it. So the question is, what do I want? Do I want pizza? I don't think so. I'll get a kebab roll. But last time I was like, didn't eat a lot of it. Or rather, I forgot about it. It's not that tempting to eat, really. There's salads, but they're like tiny. Oh my. Can you just get bread and pizza salad? I guess I'll get the kebab roll with the sauces on the side so I can eat it as a salad. That's the best. Oh, that's the wrong phone number. Wrong pizzeria. That one's too far from here. Let's see. There. So. Hej! Ursäkta, vad sa du att det ringde? Yes, men vad bra. Det lät nästan... Yes. Jo, jag vill ha en kebabpizza. Och en kebabpizza utan grönsaker. Och en pizza med bara ananas. Och då ganska mycket ananas eftersom det är bara det. Så att det liksom ändå är fullt med grejer på pizzan. Med ananas helt enkelt. Och en kebabrulle också. Och på den så ska det vara ingen tomat eller pepperoni. Extra sallad och lök. Och så vill jag ha såserna separat, tack. Pizzabröd också, tack. Yes. Hemkörning, tack. Holmbodavägen 95. Yes. Tack så mycket. Hej då. So, she asked for my address. That's so unusual. They usually just know the address. I guess from the phone number, you know? Never called there before, ever. Yeah. So, right, I was going to start the app on this one too. So now we start the camera app so we can get 2 angles. So, but I don't know. I think he left who wanted to control the robot. It's a bit dusty. It's a bit dusty. But let's take the opportunity to see if this works. So I brought this a few days ago in case, you know. This is that version. Yeah, I need to clean up my desk. And this one is cut. So this is a short test. If no one moves the robot, then I will just remove it at once. So you have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Yeah, so it works. We can use this if we want to. I'm removing the robot controls. Oh, but they're gone. So I had them off before, right? I don't know what happened. Well. So you can just redeem it again. It's quick to fix back now. I know. It's like set up and done. Let's just go back to there. And I'm getting this phone. Because I need to send a message, right? Yeah, and the robot is here, so I will notice if anyone is controlling the robot. I'll actually unplug the power because then I can like squish it a bit and it fits better. So So the message I sent, I wrote half of it before. I'm finishing it, so I'm done. So we need a bit of a smile there. So that's 4 hours, almost exactly 4 hours after he sent the message, and I reply. So let's be quicker with this one, though I had to answer that one on the computer. There. Yeah, so let's continue. Let's go. So if you change your mind, you're very welcome to control the robot. That's okay. It's just to redeem it or ask me. It's 1 point, I think, to redeem it, so it's not like it requires a lot of points. But maybe you're like me and prefer doing the buffer overflow. So let's see now. The pizza is on its way. They usually take like an hour, so I'm not worried it will be very quick. We'll see. Right, we have this question. I don't see really. Let's look at what the hint is. With help info in GDB, further hints can help to view the process and their information. Submit the size of the stack space after overriding the EIP as the answer. Format. So the first thing is that they don't say what state it's supposed to be in the program. After overriding the EIP could suggest we're supposed to have that breakpoint still. But it could also be like at the end of the program, because we still have done that then, and that's like the natural place. Right? But let's do help info. So, right, let's turn off the light there. So info. I mean, stack space. Stack. Okay. Info stack. Type. Corrupt stack. Oh, right. So let's add that breakpoint. Bullfunk? Why would I remember that? That's useless. Anyway, let's run it again. Restart. And let's do stack. And this is what we have now. And I'm not sure what really they want here. View the processes and other information. So maybe we should look at this. Process information. So info proc. So let's do info proc. So process warning. Unexpected null character. Command line. Seriously. Yeah, so last time we didn't do this one at the end, and we started with that next time today. But let's actually Google on this question, because I think it's very odd. I want an explanation. I have completed the whole study plan, but I can't figure out how to answer this question. Did you end up figuring it out? I have the same question. Info proc all. I needed to work at the host provided at the question using VPN once the program stopped. And looked at the stack size. Yeah, so infoproc all maybe then, because it said infoproc, right? Infoproc all. Okay, so we have more information. And it also said when the program stopped. That's not when, but also they might say when the program stopped, when it stopped at the breakpoint, right? So we have the same lines at the start, then we have mapped address spaces, and for stack here, this is a number we have. So let's paste this and see. So obviously this, I don't know if to call it a room or whatever you call this, right? It's not obvious. It's not at all anything. So I think that you should have a chance, or even something hinting at that this is a thing. You should learn the things you're asked to answer, right? We haven't looked at any help at all. They have not mentioned help exists. And now we're supposed to Google and find this kind of thing. Right? Yeah, the info should definitely be in. Yeah, so there's lots of people. This one has 4.7k likes, and it's from okay, so from 21 to 23, and they still haven't changed the task, and it's on their own forum. That's bad. That's just bad. I'm not saying Try Hack Me is perfect, but you know, when I said like, hello, the burp rooms are ancient. Can't you fix this? And a few months later, when I had finished them, they were gone and I had to redo them. So that's good, right? But other things, I don't know if they're fixed. I haven't done them again. So what's this? This is, oh, Alf. Right, so look at that. So, let's continue. So we solved this. I guess we should add this to our GDB information, right? We can see things about mapped address spaces for a process. Submit the size of the stack space after overwriting the EIP. So the time is not certain, and what they want is certain, but we don't know how to get it from what we learned in the room. That's the problems I have with that. So we did set the breakpoint for, and now I don't think they wanted the breakpoint, right? Because I didn't add it. I added it. I don't remember. I don't really care. So info. Info. Proc. All. Less information about the current process. Including what memory is in use. There. That's a kind of long one. So I guess we're not done with this one though. And I'm not saying that like in a negative way. I guess it's good to know that this exists, but I would have liked to hear about it instead of Googling it. I assume that I learned things on the academy, right? Identification of the return address. Right. After checking that we still control the EIP with our shellcode. Yes, I did. We now need a memory address where our knobs are located to tell the EIP to jump to it. This memory address must not contain any of the bad characters we found previously. Right, of course. That's a good thing to think about. So let's hop back to buffer overflow and let's check quickly through the notes, because I probably have this somewhere. I'm not sure. So these notes are kinda new. Memory layout, stack frames, program structure as program. Let's maybe flow. Program flow in as. Yeah, I was going to. What happened? Can't I right click it? What did I do? Now I must undo. I know I missed a lot of letter. Missed a B. So when I've been typing now, I'm thinking, is something wrong with my keyboard? Because some characters, maybe there's too much bread pieces in there from eating bread here. Anyway, buffer overflow. Yeah, and a pearl and the echo one. Exploring memory. Yeah, so now this is where we want to move this one, right? Or maybe we will keep it here. Because we might want to look at memory already here. That's kind of the thing, right? Example. Confirm buffer overflow, length of the instruction pointer, test position. And this didn't really do this. Find bad characters. using shellcode, generate shellcode, example shellcode from TryHackMe, running. Oh, I'll close the door. So I heard my hubby talking in the phone when he got home. So there. So what did I mean here? I thought we were going to finally run it, but we didn't. Test run. Test run. Now let's actually do the find the address. So we generated it here. So let's move this. So we generated it, and we don't need to have it twice. We have the shellcode, and we have the command to run. We confirm that we entered the format we supplied with Python. And here, let's confirm that this is what we have in our last run too, right? Oh gosh. There's more. We didn't see all of it. Cool. I'm assuming then that there's more than all. So I'm starting to get hungry again. The pizza should come soon-ish. Should I get more sandwich piece? That's right in front of me. Probably not, right? Though I'm not getting pizza, I'm getting kebab also. What was I going to do? Check the memory. Do we have this already here, right? There. So let's see. So first of all, we're really looking for our knobs, right? So what did I do now? Oh, I didn't run the last one. Oh gosh. I think it's lagging a lot. So this is what I just run, right? So let's run this again so we know what we run. We have a lot of 55s. There. And we're stopped at the breakpoint. Now we check. Like they had 2000 here, which felt a bit crazy to me. Here we have the 55s. We have the knobs. So the start address of the knobs is here. So we could take like anything here, really, right? And there. We just have the start of the code here. So what I was going to do was to check if it's the same address. So no, it's not. It's not the same. So I'm going to check on. Am I going to check on theirs? They're doing, yeah, I thought so. A much higher number. So, and then they don't need this other long one. But the rest is the same. So theirs didn't work. So I'll rather go here. That means we really could do like less. $55s. And now we got the whole thing. So let's put this one in there instead. Am I like blind? So here it starts. And I remember BDCA92. Here are the B's. What? Four times, not two. Anyway, we can select an address that does not contain these numbers we're not supposed to have, you know. But I'm still... So, 26, 3C, I found them. Here. Here's the address. It's supposed to be. So that means that we copy this. And copy. I'm like, do I want to redo it to make it even and nice? Maybe I do. Because it will be in my notes for all eternity. And it's just the printing out. So, 5 minus 5. If we were to do 1 less, if I were to do 5, what? Yeah, so I did 2000 last time, and now I did arrow up and I got a 600. Why? Okay. 305. That's probably correct now. So here they start. We'll see. Yeah, it seems like off. Still. Was I counting wrong? Sorry for this. It's just to get the notes pretty. There. So now we have these at the end here. That's good enough. And let's take a few lines of these. And I'm going to remove the whole note. And let's add this instead. Let's actually make a new one and see if it's the same, even though it didn't look like it at first. So D7A1, and here we're on D1. Yeah, so I was right, it's not the same. That's why we're making a new one. So we have the knobs. So how many spaces was that? Let's better copy it and paste here. Shell code. And then we have 66666666 represents the instruction pointer position, represents the spot where the instruction pointer will be restored from. That's better. Not the spot, the soft. So maybe I should just not have this money here either. It looks ugly. Yes, we got another reply. I'm just telling him I fell when I was standing. Oh my god, and I wrote in English. No, I'll have to answer later, because I can't type in English to Swedish people. That's too odd. Brain, wake up. Yeah, it's Friday evening, right? So, it's currently almost 19.
Fixit42 bot says welcome back Cypher Enigma.
Hi, welcome back. Alright. So,
Cypher Enigma says howdy howdy.
howdy howdy. Yeah, so we're supposed to check the address. I know that, so yeah. Like something here, they're probably saying D64C. Yeah, this one they were taking. And they're putting it in there. So, no, but the address is entered backwards. So, we'll have to do it. I'm not very happy about the backwards endings. It's there and it's facts, but it's still. Let's see what we'll do. We can do this one. Doesn't have to be a lot of lines up. Let's do this one, I guess. Right. Let's select as our start address, right? And let's do a
X Hack the Planet X says yo.
Yo, hi there, welcome in. Buffer overflow. So let's change what we had previously here. Or we can do the whole thing. So let's just do we here. Sometimes I do let's a million times, right? Especially if I'm doing like writing what I'm going to say later. Let's do this, let's do that, like an instruction, you know. So let's do this now. It's okay when you say it, when you type it, it's just odd. So 4 and FF and FF and D7 and 3-1. And let's copy the whole thing. And let's go to our other screen. And I just want to get rid of those there. Yes. And this time we're at the breakpoint. So I don't know. I have to check my notes. How do I continue running it? continue or see.
Filmar du eller?
Yes.
Hade du beställt?
Yes, jag har beställt.
Okay.
För länge sedan då. Så det borde komma snart. So my hubby wondered if I ordered pizza. I did. So we got an illegal instruction here. So let's see what they say. I probably didn't do what I was supposed to do, right? But I recognize this problem though. So let's see. First of all, let's check the address. D7 A7. So this is the kind of thing that I got before when I got inserted stuff into my input. So this one is gone, and instead we have an A7 there. So let's see. We didn't follow any instructions, so let's do that. So identification of the return address. After checking that we still control the EIP with our shellcode, we now need a memory address. I didn't do anything stupid like use one of those I'm not supposed to use, right? Just have to check here, because that will look like that. So 4C and D6, they're not in our forbidden characters. Gosh. So also we should not have that. So the highest one is 20 hex, meaning these should be okay. Oh, try hack me, it's 19. Then I have try hack me popping up and reminding me that it exists, right? We now have to choose an address to which we refer the EIP and which reads and executes one byte after the other starting at this address. In this example, we take the address D64C For us, that would have been in the middle of the fives. I don't know why they're not just knopping all of the thing. Why they want the 5 5s there too. Whatever. So, in this example, illustrated, it then looks like this. So, buffer, knobs, shellcode, and the address there. After selecting a memory address, we replace and overwrite the EIP and tell us to jump to this. Note that the input of the address is entered backwards. Note, identification of the return address. So 4CD6, 4CD6, FFFF. Since our shellcode creates a reverse shell, let's netcat listen on port. Yeah, this very much works. Not. Did it just work for them? Snap and address. ID. It just worked. Okie dokie. And we did the same thing. So as I said just a sec ago, let's just confirm that I didn't do anything odd. So 3 1 D7, so it should be D7 3 1, D7 3 1. It should end up in the middle of the knobs, right here, and then it should continue with this. And it would have if it had the right address at the end, which is where. So we don't have the 6 again. Right. I just realized something. Let's compare. Maybe we need to turn off the randomization. Maybe we need to do that manually ourselves, because I did not. So let's see if it's on the same address. But I checked the address and it was correct. So I already did that. Well, let's do it again. So shellcode. I didn't check it for the new one. So this is the new one. It was the old one. So here we have all the 90s. Yeah, it's on a totally different address. So I need to turn off the address randomization. And I can do that. I thought it was like pre-done here. So it's on a new address. So it's not on D7 anymore, it's on D1. So of course it goes bananas. Wait. Maybe it is still on D7, and that's just me that didn't click enough. Because I saw 90s over there too. That's why I thought I was in the right place. Yeah, so it is still on the right place. It's the same. And then we have on A1. A1. No? Here. So here we have where we wrote the address, right? And it's supposed to end 2-6. So let's see here. This is supposed to be F5, D7, 2-6, 3C. And then it's supposed to be our address. It is 3-1 D7. So what didn't work? It might be afterwards then. Now I have to start the listener, though I didn't update the part, so we'll have to change and listen to this part. And I'm like, what? No, we didn't use any IP. This is why I went like, what, dude? Should we listen on this machine for stuff from this machine? That makes me so what? So the IP is 127.0.0.1 that we used when creating this as their instruction. The L host. There's I guess L host and L port. So I want, like, you know, the maybe L is what they're using. But anyway, it's localhost. Why? This is why I thought we would do something more. Well. It's just odd. Very odd. I've never seen anything like this. Is this normal HTTP Academy? I've never seen HTTP Academy before. Alright, we have this one. So let's close that one. Let's arrow up. Yeah, it's finally understood that it's down because I couldn't click anything. So, and now we need the connection information. Let's scroll down. So it is still there. It's just so much odd things. I'm going like, why? What happened? Why didn't it suddenly be there, right? So this box is still up. It is the same one, I think. I don't think it's a new one. And I feel like I'm complaining all the time, but I think, like, what? What happened? So we're supposed to... Do we have Netcat here? What on earth was the port? $31. 337. It worked. Okay, so let's run this one again then. So it is at the breakpoint, which is the start of the function. So if I do C, so we got a connection, but we had to go to this one. It's just not logical to me. Why wouldn't I want it to my machine? Why? Yeah. Alright, how cool. We're on the same box we're SSHing to. From the box we're on this box. Oh. Well, it works. I guess I shouldn't complain. It worked. That's good. So I should go next, because it was at the end of this that I didn't have anything. It was empty, waiting to start. Will it start anything? So, after starting our Netcat listener. Yeah, and here you can see they do it on there. I don't understand the person who made this. And why they did it like this. if someone is learning buffer overflow, don't you assume they know how Netcat works? And that they know what their IP address is on the VPN? What do you think? Oh, I don't think anything will happen here. Let's just go to the next one. It seems like it is done, but I'm not sure. It has this like points too, right? Doesn't it? I'm going to... No, it can't do that even there. Public exploit modification. So a short bit here, short bit there, skills assessment. So I don't think we have much more facts in here. We want the facts. So public exploit modification. It can happen that during our penetration tests we come across outdated software and find an exploit that exploits an already known vulnerability. Exploit that exploits. These exploits often contain intentional errors in the code. These errors often serve as a security measure because inexperienced beginners cannot directly execute these vulnerabilities to prevent harm to the individuals and organizations that may be affected by these vulnerabilities. To edit and customize them, the most important thing is to understand how the vulnerability works, what function the vulnerability is, and how to trigger execution. So it's oddly written. What function the vulnerability is in. What category of, what type of vulnerability it is, I guess. And how to trigger execution. With almost all exploits, we will have to adapt the shellcode to our conditions instead. It depends on the complexity of the exploit. So, if this is a instead, there should be a negative before. It plays a significant role in whether the shellcode has been adapted to the protection mechanisms or not. In this case, our shellcode with a different length can have an unwanted effect. Such exploits can be written in different languages. With our shellcode with a different length. Can read different languages. So they're talking about making them shellcode now, I think, but it doesn't sound like that. The exploits may be different from the operating system, depending on the operating system. Probably resulting in different instruction. For example, it's essential to set up an identical system where we can try our exploit before running it blind on our target system. Yeah, we have to test stuff. Such exploit can cause the system to crash, preventing us from further testing the service. Since it is part of our everyday life to continually find our way in new environments and always learn to keep the overview. We have to use new situations to improve and perfect this ability. Therefore, we can use 2 applications. So I'm assuming we will have something else to play with, or what? So, prevention techniques and mechanisms. The best protection against buffer overflows and security-conscious programming. Software developers should inform themselves about the relevant pitfalls and strive for deliberately secure programming. Besides, there are security mechanisms to support developer and prevent users from exploiting such vulnerabilities. These include security mechanisms, canaries, address space layout randomization, data execution prevention. So, nothing to click. We already have these in the notes. And the notes are public, and it's in modern security features here. So, the canaries are known values written to the stack between buffer and control data to detect buffer overflows. The principle is that in case of a buffer overflow, the canary would be overwritten first, and that operating system checks during runtime that the canary is present and unaltered. Address space layout randomization, ASLR. It's a security mechanism against buffer overflows. It takes some types of attacks more difficult by... It makes some types of attacks more difficult by making it difficult to find target addresses in memory. The operating system uses ASLR to hide the relevant memory addresses from us, so the addresses need to be guessed. Where a wrong address most likely causes a crash of the program, and accordingly only one attempt exists. Data execution prevention, DAP. DAP is a security feature available in Windows XP and later with Service Pack 2 and above. Programs are monitored during execution to ensure that they access memory areas cleanly. DAP terminates a program if a program attempts to call or access the program code in an unauthorized manner. And to add something there, for example, the stack marked as should probably be non-executable here. This was from TryHackMe, I think, or I don't remember. So I should probably fix that. This is to prevent users from putting shellcode in memory and running it by setting the instruction pointer. Exactly what we just did. Countermeasure ROP. Knock on the door. Yes? Ja, men pizzan kommer ju snart nu. Vill du ha det först? Men vill du ha det nu då? Det har inte jag heller, middagen kommer ju snart. Men lagom, pizzan kommer när som helst. Du får det först, okej? Okay? Den kommer jättesnart, jag lovar. So my oldest, he did order pizza now, and now he wants spaghetti just when it's about to arrive. So let's see, how long ago was it that I ordered? Should be here anytime. So, let's see. Reasons. 1817. It's more than an hour since I ordered pizza. I understand he's hungry. This is annoying. That's a long time. So, I should have given it earlier. Countermeasures. ROP. Return-oriented program allows upload of shellcode to an executable space, then uses accessing calls to execute it, requiring also memory addresses of things are stored. ASLR tries to prevent this. So let's go to the second to last one. Or is it the last one now? Okay, so We were able to gain SSH access to a Linux machine whose password was reused by another machine during our penetration test. On this machine, we have standard user HTTP student, who can leave a message to the administrator using a self-written program called leave message. Since the target company pays a lot of attention to defense from outside their network, the administrator's appearance showed high self-confidence. It may indicate that local security was disregarded. After our research, we found that these messages are stored in HTTP student message txt, which is a binary owned by user root, and the SUID bit is set. Okay, execute the program and find out if it's vulnerable to stack-based buffer overflow. If you have found the vulnerability, then use it to read the file root flag txt placed on the system as root. Poof. What? That's proof. My god. Yeah, it's too late. I should stop. But this is like the end of it, right? Warning each time you switch your connection. So. Okay. The food should have arrived. I feel bad for my 16-year-old. He's real hungry. He's stressed to get to sleep because he's been having bad times. Sleeping times. Sleeping hours. So I'll have to do this next time, or I'll do it myself. It's just doing the same thing again. But I'm thinking as it is SUID, we can use the track me shellcode in case those characters, of course, are not like forbidden. Or let's see. Yeah, I think it was with the image. Here. So we can probably use this. So it just runs. It's done for SUID. So, but maybe that's not compliant with their questions. Yeah. Stack space and stuff. So we're supposed to use the same one. Exactly, probably. It doesn't help only to do this one. So I really don't like the hack the box with several questions. I just want the flag things. So yeah, I think that was just checking off everything. So what is go to questions? Anyway. Yeah, it's time. Let's go to... I'm already here. It's just so many things there, so I can't recognize it. This is interesting. So, who is this? Who is this? Redsec week 2. Demo time. Student run security oriented club. at Rochester Institute of Technology. We meet Friday. Well, interesting. Then we have, what are they doing? Office hour. That's not very interesting, is it? They might do something later, will they? I like active people who are doing something. I didn't even mute this one, right? Can you hear anything? Maybe you have double audio on and I can't hear it. Yeah, so I should have this on and it should work. Yeah, there's no desktop audio now. What if I unmute this? I can't see no desktop audio still. But it kind of looks like it's muted too. What about this one? Nothing? No desktop audio. Oh, it's muted.
The constant renewal is
Okay. Yeah, so. I'm like thinking, let's go to the channel. I don't want to raid someone who's not really there, you know. Maybe we'll do it anyway. Let's do Clockio. Yeah, let's read Clockio. I haven't done that. And he is he works as Sneak. He does security stuff, but not maybe on stream. Let's see. Clockio. So there, we'll see. And something is wrong. Am I like, yeah, I'm muted. So if I mute there and unmute there, I should be able to hear him, right? So yeah, right, I forgot to put it on YouTube too. I'll put the link there when we hop over. So thanks very much for being here today, and I know that we've been like different numbers, but I think we were up to 9, 10 at some point at least. Oh, on Twitch I haven't seen how many people on YouTube. So thank you very much for today, and I have lots of fun doing this. So it'll be kind of fun to do the next bit of this because it'll be more of a challenge, right? So bye.
Firefox down.
With 5 views.
Thank you, Fixit42.
Fixit42 just raided us with 5 views.
Welcome in everybody from Fixit Stream.